Hello, everyone. Welcome to the stream. I realized I had the window in the wrong place. There we go. You got a split-second view of the bucket there. You too can see the bucket if you support us on YouTube or Patreon at the appropriate level, at windmill level or higher. You can see the bucket of all the puzzles that have ever existed that I've put in there, and vote on what puzzles you want to do. So today we are starting with this puzzle, Super Smashboy by Pesto, which is the most voted on puzzle in the bucket by those of you who support at the windmill level or higher. So just to start with who voted for it, Woofer, Nordy, Ken, Doomdiat, Luda, Josh, Russ, Chameleon, and David. So this solve is dedicated to all of you. And so if you want to become a supporter so you can vote on what puzzle I do next, you can do that by either clicking the join button down below or by going to patreon.com/zetamath. There we go. Those are both options. What other news do we have? We've been getting tons of awesome pictures of Zach recently. If you would like to make an awesome picture of Zach, please do. But Isabella made a particularly awesome picture of Zach. But we've also been hearing some conversation about Zach merchandise. Notably, no one has asked to have me on their t-shirt, but many people have asked to have Zach on their t-shirt. So we're in the process of looking into that. So at some point in the not infinitely far ahead future, you can look forward to seeing the various Zach-related merchandising options. All right. So let's get started on this puzzle. Zach Bucket Hat. That sounds perfect. Did I read the list? I did read the list of people. Yes, I did read the list of people who voted for this. So I got to stamp down a betting tree. So we'll stamp down the betting tree there. So you might want to read far enough in the rules to see that we're putting the digits 0 through 9 into the grid before you decide what you want to bet the betting tree to be. But if you're not familiar with the tradition, the almighty week and a half long tradition of the betting tree is a cell that we pick early in the solve, and then people try and guess what value will go in the betting tree at the end of the puzzle, provided that we successfully solve the puzzle eventually. So that is there for you. David bets 7 since today is the 7th. That seems like a good strategy. Okay, so these are German whisper lines. So digits along a German whisper line have to differ by at least 5. Note, even with a digit 0 through 9, differing by at least 5 still means you alternate high and low and high and low, except that now 0 is an honorary low digit and 5 is an honorary high digit. So we have that. Every cell belongs to a 5-cell region. So we need to break the board completely into pentominos, is the the short version of that. No two regions of the same shape, including rotations and reflections, share an edge. So this is a pentominous puzzle, in a way. We're breaking the grid entirely into pentominos. Happy Independence Day to Isabella. It is Brazilian Independence Day, I am being told. Okay, and then clues in the top left corner give the sum of the digits in that cell's pentomino. And the clues appear in the uppermost row of that region. So this rule, we did earlier Smashboy, the first version earlier, so we've seen this before. That turns out to be really important. Okay, so the thing we have to start with is drawing in all of the lines that we know are there. So the 33 pentomino and the 35 pentomino are not the same. And the 33 is not the same as less than or equal to 19. Note, a pentomino is allowed to have more than one clue. So we do have to be slightly careful about the possibility that 2 of these clues refer to the same digit. And by the way, always putting a top row bar in, because we know the top row, or we know this is in the top row. Let's see. That is in the top row. That's 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 in the top row. Oops. And that's in the top row. A question mark. Lovely. This is in the top row, and that's in the top row. All right, so we've got lots of sort of immediate color extension we can do. So this needs to get to 5 cells in total. It has only one way to escape, which is to go this way. So we know that those are both orange at the very least. This 15, it might go down, but even if it does go down, it still has to get out over here by at least this much. In fact, actually, oh no, I don't know the 15 and I do know the 15 and the 19 cage are different. So this is a piece of logic we had to do from before. The 15 and the 19 cage have to be different because this is the top row of this and this is the top row of this. They're in different top rows. So now I was going to say yellow can't go down here. That's correct. Yellow cannot go down here because now the 19 cage would be broken. So yellow goes there. And we get all of that. And I might as well say that same thing. And now let's talk about the 19 cage. So the 19 cage could come here potentially, but even if it does, it still has to go there. So we have that looking like that. Let's see. This we know, I suppose I should have started with this. This is an I pentomino because it's not allowed to leave the bottom row. And it might take this cell or it might not, but it always takes these 4. So we've got that. And so now this cell, whatever it is, it might take this cell or it might not, but it always takes that cell. Whatever this is, it has to get out. So we've still got plenty of it has to get out easy moves. The coloring part of these puzzles is always my favorite. It's all downhill after that. But this part is super fun. I really enjoy this sort of like this has to get out. This has to get out. I enjoy that greatly. This is not the same region as yellow. So yellow has to keep going. So yellow goes down. And now yellow's still not done. So yellow has to grow to the only place it can grow. So yellow does that. Now green has to keep growing now, at least to there. And now I can label up this 32. The 32 has to get out. The 32 and the 14 are different. So now the 14 also has to get out. So let's see. Let's make this another purple. So the 14 gets out at least to there. Let's see. This 14 also has to get out. So whatever it is, it's going to have to get out actually even further than that. It's going to have to get out at least to here because of this 30, because this greater than 33 is not the same as 14. So let's see, this one, let's make that blue. Da-dee-dee-da-dee-da. Oh, and so orange is done. So orange does that. And so orange is a long L. The 33 has to do that. And in fact, because remember the 33 can't go up, the 33 actually is going to be forced to be an I. Because this 33, it's not allowed to turn down because it would be an L touching an L. So actually the 33 cage is just an I pentomino. Let's see. I'm sure we have other juicy stuff going on somewhere. This 10 cage. Oh no, the 10 cage could be the question mark cage. Annoyingly, I think the 10 cage and the question mark cage could be the same. So the digits in this, I'm going to start filling in digits. If I'm totaling to less than 11, less than or equal to 11, I'm either 0, 1, 2, 3, 4, or I'm 0, 1, 2, 3, 5. Those are both possibilities. Isabella says question mark and 10. Oh, because I know this is an I pentomino. Right. I don't think having 18 clues and 18 cages tells us anything, Nicholas. There could be cages with no clues and cages with 2 clues. But Isabella's point is correct. I know this is an I pentomino because it can't escape the bottom row. And so therefore this cannot possibly be an I pentomino. And if it connected to the 10, it would be an I pentomino. So the 10 is different from the question mark. And so the 10 has to get out this way, at least that far, we know. Let's see. Afraid Not says this is forced. Sounds plausible. So if these are... So the absolute The absolute maximum I could make these sum to is 17. If I make this a 3, that would be 20. So I need these to sum to at least 13. That seems like there's... Oh, it would have to be 6 and 7. That sounds likely to be true. That is forced to be exactly that combination I just said. But I don't know that we want to try and prove it at this particular moment. Let's see. I feel like we could probably do some logic on this stuff up here, but I don't quite see it right away. This 14 cage definitely contains a 0. If I did not contain a 0, how did I switch to the letter tool? Please get me out of the letter tool, thank you. Then I would sum to more than 14. So I might be trying to make some sort of complicated fish on zeros. 35 is what... 35 I actually know. This has to be 5, 6, 7, 8, 9, because those sum to 35. That's the only way I'm getting to 35. I see 2 options for the green question mark. It could do that, or it could do that. I guess that means the green question mark always... Oh, no. The green question mark... Could the green question mark do this, even? Oh, the question mark is in the top row. Right. Sorry. The question mark is in the top row. Right. So actually, yeah, this is just completely forced. Yes, I agree with chat. Rules. Yes, who reads the rules? And so now blue is forced to do that. This is still 0, 1, 2, 3, 4, 5. Oh, well, the 10 cage, remember, is... This also can't go up. So the 10 cage has to extend to its right. So that is at least also there. Let's see. The 10 orange needs row 10, column 7. The 10 orange is exactly 0, 1, 2, 3, 4. I should fill in. And hey, Tirganus. So this is low. So I actually know that this is high, which includes a 5. And this is low, just by German whisper stuff. So people are talking about the 10 cage. So the 10 cage can't be an L or an I. So if the 10 cage comes to here, it's already broken. Because if it comes to here, it can only be an L or an I. So the 10 cage has to change direction. So it can only turn down. Afraid Not is making this point. And then once it's there, then it has to go there, and then it's done. And so these are 0, 1, 2, 3, 4 as well. So this is 5, 6, 7, 8, 9. This is 0, 1, 2, 3, 4. Oh, why couldn't it be a Y? Oh, you're right. You're right. It could be a Y. Never mind. Sorry. Never mind. I was completely convinced. But it's incorrect because it could come here if it does that. That's allowed. I guess. So it always takes this cell. Because if it doesn't take this cell, then you can say, so it takes that, and then it's in that position where it doesn't have any options. So this cell is always orange for whatever that's worth. And so that gives us a... so it tells us that there's this sextuple in the row, which tells me there is a 5 in this less than or equal to 11 cage. But now, because there's a 5 in the less than or equal to 11 cage, because the 5 needs to be somewhere in the row and it's not here, there's now no 4 here. Because if I had a 4 in here, then with a 5 it would sum to too much. And so we get our first digit here, which is a 4. And we get to have bring in our digit dancing penguin to do our 4 dance. Ba-doop, 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 boo, boo-da-boo, ba-da-ba-doop, 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 ba-da-boop. Thank you, Zach. Thank you very much. A lovely 4 dance, as always. Somehow Sven software doesn't know that these can't be 4 anymore. That's right. So now orange actually can't go here. So now actually orange is a Y. So we have this coming over here. This is a 0, 1, 2, 3. So we know that these are each big. They are 5, 6, 7, 8, 9. This one I know is not a 5 because of the way the row works. In fact, I should go ahead and fill in that these are from 6, 7, 8, 9 for sure. So now there is a pentomino here. And so let's just fill it in carefully. So I'll start by making that yellow. It certainly has to get out. Now it could come up here and become the 34, or it could try and avoid becoming the 34, but even if it tries to avoid becoming the 34, it doesn't succeed. Because even if it comes here, well now if it's trying not to be 34, it has to come up, but now it's enclosed 34, and so it has to be the 34, and as soon as it is the 34, then we get that. I suppose alternatively, you could have just asked what cells can the 34 possibly take, and if you asked that, then you would get that appropriately. So now we can use this less than or equal to 34 clue, I think. Yes. So maybe? Well, let's do the 20 cage first, because the 20 cage is now completely given. 3, 4, 5, because this 20 cage now can't do anything but eye around. So we will do that. Do we have enough colors to give each pentomino its own color? Because I've noticed we've made the eyes blue. Maybe we can try and do that. I'm noticing that this digit is always at least 4. And so if this digit is not exactly a 4, then this would be 5, 6, 7, 8, 9 as a quintuple, and that would be 35, not less than or equal to 34. So in fact, this is a 4. It has to be a 4. So we have that 4. Yeah, that's what I was saying, I think. Is that it has to be less than. If this were a 5, 6, 7, 8, 9, it would be a quintuple. And then this would not be a 4. Because the sum would be 35. And 35 is not less than or equal to 34. But now anyway works. Because either this is a 6, 7, 8, or 9, in which case it's 34. Or this is a 5, in which case anything goes. But that means that these are from 5, 6, 7, 8, 9. And actually, now that I fill in that for the row, I know that the 5 in this row... Sorry, the 5 in this pentomino is here, because this is a this is a quintuple. Sorry, I just wanted to say sextuple. And so now that 5 knocks this 5 out. And so now this is actually a quad. It does actually sum to 34. So we've got all of that. I'm missing a border on the 20 gauge. Oh, yes, thank you. Was almost a disaster. So this 34 cage is always at least taking this cell. I am just seeing that. I am, for the first time, appreciating that this 34 cage exists. Row 8, column 3, can't avoid redness. If this were not red, then red would have to get out around it somehow, but then I'd have to fit an entire region under here. So I agree with Olima. This is always red by squeezing logic. That is often in these puzzles, the kind of logic you have to apply is the, okay, if this is not red, then it has to be an entirely new region that I then have to fit underneath red, and that's not going to work. Row 8, column 4 does indeed have exactly the same issue. Actually, wait, could row 8, column 4 be this yellow? No, oh, wait. It could, couldn't it? Couldn't it be this yellow? I think this could be this yellow. No, it can't be, because then that would make it... That's too big. Because now red can't finish. Wow, that's gross. I don't like it. But yeah, this can't be yellow. And it certainly can't be a new region. And it certainly can't be purple. So it had better be red. Let's see. Is it true? No. I was hoping that this cell couldn't be yellow, but unfortunately it... Oh, it has to be yellow. Right. As Liam phrases it, yellow can't be an eye, because it's touching an eye, and so I can't stay in this row. I have to go down, but this is the only down cell it can have, so those are both forced to be yellow. And now this can't be yellow, because if yellow took this, it would be a Y, and yellow already touches a Y. So that's yellow. It is of note that the 34 cage is completely forced, because it's 4, 6, 7, 8, 9 is the only way to do it. Red is now finished, Tristan points out. I agree that red is finished. And so now purple has to get out. Purple gets out there. This 24 cage now always needs to take these two cells because I can't squeeze a region around it. So this 24 cage always takes all of these, whatever it may be. And then we know how it finishes because it can't go up. So now it just has to take that cell and it's done. Because I could not fit an entire cage under the 24 cage. There was not enough room. So the 24 cage is now sort of set in stone like that. Purple is now forced to eye around, as Tristan points out, so it can become blue. The joy of having the multicoloring again. I've been doing a lot of Sudoku setting at work lately where I don't have Ranks mods installed, so I don't have the double coloring, and I miss it so much. So this is an eye. Let's see. Greater than or equal to 32. Ah, there's a border hanging off over here that is missing. In fact, I'm just going to go ahead and ring the entire border now so that I will make everyone happy. There, that makes everything look bolder. I like it. So whatever Amino starts here, actually, it's going to get out and get at least to the bedding tree. Let's make it yellow. It can't be an L. So actually, oh, it could go like that. Or it could be a Y, and it could, oh, I don't think that works. I don't think it can do that. Because this region is now squeezed. Because this region, oh, it could be, no, it can't, oh, it could be yellow, sorry, it could be yellow if it's a Z. Annoyingly. This 30, oh, the 33 could come down here. Sorry, I was going to say the 33 needs something from down here. But whatever. Yeah, orange is having complicated issues fitting with the things. So orange in particular can't be a P pentomino, which is the thing it really wants to be when it grows up. So is orange actually forced to be an this thing? What is that? I thought that was an L, but I also thought this was an L. I don't know. Oh, this is a V. This is called a V, is the fancy name for it. I think orange is forced to be a V, right? Can anyone imagine a universe where orange is not exactly this V, where orange finishes? I cannot. Hey, Hexspeed! We're just going to go with it. Okay. So now this indeed is forced to become yellow, exactly as Isabella foretold. It is almost as though Isabella is very good at this. This joins the 33 and comes out. Actually, this is just forced to be an L. It has no choice. If I just start here and keep going, it can't do anything but this. So we will make that green. Can box it. Wait, didn't we just break the puzzle? No, we didn't break the puzzle, because now purple is going to have to be an I. And so because purple is an I, yellow can't be an I. Yellow can't come down here, so yellow has to come down here and make yet another L. And now purple does its I thing. So purple is going to go out like that, making purple into blue. As one is wont to do. Oh, I know now that these are from 5, 6, that these are 5, 6, 7, 8, 9 quintuple. Let's see. Whatever this is, it's going to have to go in. But actually, whatever this is, okay, this is, I think, the place to look. Whatever this is, I'm going to go make all the L's purple real quick, because I don't have any purple in the grid, and I would like to have purple in the grid. So all of the L's are going to be purple now. That way there will be a lot of purple. Okay. I think the question is about this cell. So this cell, which I'm just going to make red for the moment, is going to come out like this. Ah, this is another purple. Good point. So this is going to come out like this. I think this cell also has to take this cell. Or I think this region has to take this cell. Because if it doesn't take this cell, it either is an I or it's an L, neither of which it's allowed to be. So I don't know exactly what it is, but I know it takes that cell. Actually, I do know what it is, because it can't go down, because then it isolates this cell. So, oh, sorry. I mean, maybe I still don't know exactly what shape it is, but I know it doesn't go there. So it's going to take one of these and either be a Y or an N. Hey, welcome, Math Pesto. Hope you're having fun. Karaoke Spice Girls. Excellent, excellent. Okay, so now I should write in this region. like this. And so now this region also has to avoid being an I, an L, and also being whatever red is. So green, interestingly, can't come here. Because if green comes here, how does it finish? It can't finish there, and it can't finish there, so it finishes like that. But then how does red finish? It finishes like that. And so if green comes here, I get two Ys. I can't have two Ys touching each other. So green actually has to stop there and go up here. And so now red comes over here, and so red is finished. Red is a Y. Green is finished, and green is an N. And then we've got a little C over here. Let's see. Let's make all the... Let's see. Should we do yellow? Should we use yellow for C's? We'll do yellow for C's. Or U's. It's a C. I'm allowed to call it a C. I don't think there's anything wrong with that. We'll do red for Y's, so we will temporarily de-red this region. So that I can red all the Y's. And then we can, let's say, green the N's. So I have to ungreen this and ungreen this, because they're not N's. And so they are, in fact, P's. What color am I going to make my P's? I think I'm going to steal orange for the P's, because orange is a cool color. We'll steal orange for the P's. And this is also a P. And now, what color have I not used? Are there any good colors I have not used? I have not used green, purple, orange, red, yellow, blue. Oh yeah, I've got to use a kind of crummy color for this. Perhaps I could just use the letter tool and just write A's across it. People might like that. Alrighty. So sorry you missed the end of your, or only got to come in at the end of your puzzle, Math Pesto, but I enjoyed that very much. It was very nice. We got all the coloring done. Oh, did I originally call peas green? I might have called peas green. Or maybe this is a pun about green pea soup. I do like green pea soup. Green pea soup is good. Anyway, we can actually finish the rest of the puzzle, I think. Now 1 hour of irregular Sudoku. That is usually how this goes. Let's see. The row 433. Okay, so yeah, so the... Oh, Lord. So we have to try and force this, which sounds agonizing. So the naive thing to do here would be to say, okay, the biggest these can be is if they're 8 and 9. They certainly have to be high. And so if I make these 8 and 9, these 6 and 7, and this a 3, then this is 17 plus 13 is 33, and that's what we get. There's no way that I can make this higher without improving it. So yeah, this really is the minimum. Okay, this is not as terrible as I thought it was going to be. This really is the minimum. And so that is a 3 and a 5. So none of these are 5s. I think Sven should make it so that if something is entirely outlined in a border, then it applies the killer logic to identify whether repeated digits. Okay, so the rest of this row now, and this is Jaleb's point, is 0, 1, 2, 3, 4. That one's not the 4. This is interesting, because this 33 now, there's no way this can be a 0, a 1, or a 2, because these digits sum to at most, in fact, they sum to at most something less than 30, because 6, 7, 8, 9 would be 30, but they can't even be 6, 7, 8, 9. So this has to be the 4 in order for that to work. That's not a 4. And now, in order to get to 33, these actually have to be 5, 7, 8, 9, because that's 29, which is the smallest they can possibly be. And so that's a 6. these are no longer 6. That's no longer 4. That's no longer 6. Well, I shan't complain if it continues having a bunch of these, oh, that's minimized, that's maximized sort of hoodiggies. 0, 1, 2, 3, 4. Sorry, I didn't actually put in the 4 is what these digits are, just by the row. That one's not a 3, I am being informed. Let's see, okay, so this I know is a 5, 6, 7, 8, 9 just by the whisper, but that's not at all interesting, I don't think. Let's see. Can I get to 32 without in 5 without a 9? 8, 7, 6, 5. Oh, 8, 7, 6, 5, 4. Is 8, 7, 6, 5, 4 32? I don't know. I'm being told that 8, 7, 6, 5, 4 is 30. Okay, so the moral is I do need a 9 here. If I don't use a 9, then I get to at most 30. And so that gives me a Jovi wing on 9s. So I can remove 9 from here. The two, and just to explain what that means, the 9 in row 7 and the 9 in row 8 are accounted for. One of them is in the 32 cage, and one of them is in the 34 cage. And so this can't be a 9, which I thought was going to do something with the whispers, but it doesn't actually. Does this need an 8? I think that this probably also needs an 8, because 9, 7, 6, 5, 4. What is 9, 7, 6, 5, 4? 9 and 5, 4 is 18. 7, 6 is 31. Yes, so this does also need an 8. So this can't be an 8. And so if this can't be an 8, these can't be 3 anymore because of the whisper. This is not a 3 either. So I could have a 2 in this cage. Yeah, I can have as small as a 2 in the 30 cage, because 6, 7, 8, 9 is 30. So I can have 6, 7, 8, 9, and 2. Oh, maybe that would clash with this cage. That seems unpleasant to contemplate. But yeah, that would technically break this cage. But that does not seem like a fruitful area for investigation. I'm going to adopt Math Pesto's suggestion that we get rid of the coloring, specifically so that we can color again, which is a very appealing option. So we're going to color low-high now. And remember that 5s are high in this adventure. So these are low, that's low. These are all high. These are all low. That's high. These are high. This is high. That's low and a bunch of highs. And a bunch of lows. In fact, all the lows. This I know is high. This is low. Killer cage math is definitely one of the worst inventions that Sudoku setters have come up with. All right, these are all high. That is correct, Nicholas. Thank you. So, chat has a horrible point, which I fear I actually am going to have to prove. I think I have to do it, but this is This is disgusting. So apologies in advance. You might want to cover your ears if you're sensitive to these things. We have to ask the question, what's the smallest digit we could put in this cage? And so the other 4 digits add to at most 30. So I certainly can't put a 0 or a 1 in this cage. Could I put a 2 in this cage? And if I put a 2 in the cage, the thing you have to realize is, then I need to make the other digits 6, 7, 8, 9. And so this would be, in that instance, this would be 2, 6, 7, 8, 9. And the problem with that is that I have a 2, 4, 6, 7, 8, 9 heptuple in the row, but that's only 6 digits. So that doesn't actually work, and that breaks. So I can't do that. So these, therefore, have to be the 0, 1, 2 for the row. So these are the 0, 1, 2 for the row, and they're blue. Okay, so people are saying this is slightly better if you add the remaining... So add these rows together. So people are proposing better ways to do this. So 32 plus 34, or sorry, at least 32 plus at least 34 is 66. Plus that 20 is 86. And so the point is these all together add to at most 4. And so we also, out of that, get that these have to be a 0, 1, because these already add to 3. Okay. So, yeah, so we do actually get, if we think to do that, we do actually get that, in fact, these have to be a 0, 1 pair in order to make that work. Let me double check my math there. So 32 plus 34 is 66. Plus 20 is 86. So yeah, so these need to sum to at most 4. And so if these sum to at most 4, this is the only way they can sum to at most 4, because they sum to exactly 4. Isn't it much, much, much cleaner with the including the 20 cage though, Jaleb? It seems like the 20 cage made that way, way, way nicer. But yes, we should do Afraid Not's broom here. So this 0, 1, 2 triple brooms us up to here. So that's a 4 and a 9. This is high because it's on the other side of a whisper. These aren't. Now, what? Couldn't that have been a 3? Oh, why on earth? Yeah, I think because reflexively I thought, oh, I have a triple of blue digits I'm eliminating, so therefore I know this digit. But that's not actually how digits work, because we have a 0 here. So it is still true that this has to be at least 8, though. This is an 8 or a 9. Got it. Okay. This is still orange. That's still true. Oh, there's a 0, 1 pair here, which makes this a 2. And so these sum to 3. So these sum to 3. These need to sum to at least, therefore, 12. So even if this is a 9, if this is a 9, then this could be as low as 3. Never mind. I was excited for no reason. I did see, by the way, the point that there needs to be a 3 in here from chat. Because if there's not a 3 in this cage, where am I putting the 2 3s in row 7 and 8? Namely, the 2 3s in row 7 and 8, one of them can go in here, but the other has to go somewhere, and it can only go here. And as soon as there is a 3 in here, then actually we know this is 3, 8, 9, and then we need... we can't do 6, 7, so we have to do 5, 7, is that right? Let's double check my math there. That's 29 plus 3 is 32. Yep, that is correct. So we get this thing here. And yeah, the 3 is up here because there's a 3 down here in this cage. So there's no 3 there, so these are orange, as Liam pointed out. Okay, so row math is being proposed by JLib. So these cells sum to at least 23, because those only sum to 1. So these sum to at least 23. These sum to at least 13. 23 plus 13 is 36. So these sum to... I did something wrong. Let's try this again. Oh, it's 12. 12. These sum to at least 12. These sum to at least 23. 12 plus 23 is 35. So therefore, these sum to at most 10, because the whole row adds up to 45. And so these sum up to exactly 10. And so they have to be 0, 1, 2, 3, 4. I've now forgotten who... I think it was JLib who pointed this out. That is very cool. So these now have to be exactly those. These have to sum to exactly 23, which means they're 6, 8, and 9. And now these are whatever's left, which are 5, which doesn't go there. So that's the 5, and 7, which goes there. So that's not a 5. These aren't 5 or in the corner. This is now low. These are not 7 anymore. Oops. Okay. Sudoku point from JLib, which is that if I ask where the 5 is in this row, it's not there, so it's in here. And the reason why you might care about that is that that it then means that there's no 5 down here. So these are only from 7, 8, 9. And we can do the same thing with where's the 4 in this row. The 4 in this row is definitely up here, because I need a 4 in that row, so this isn't a 4. Which lets us orange another cell. Of course, that's not a 4. This is orange as well, by virtue of being not 4. So now, important note, this greater than or equal to 20 cage has a 2, a 3, and a 4 in it, because I need to put a 2, a 3, and a 4 in this row. And wait, does the 4 is placed. The 4 just goes here. But that's just a complete distraction from the actual point, which is that 2, 3, and 4 only sum to 9. So I need the other things in here to sum to at least 11. Oh, maybe it's actually the opposite that's the problem. They need to sum to at most 11. Because I've got a 2, 3, and a 4, I can't use a 0 or a 1. So what am I putting with 2, 3, and 4 to make the sum 11? The only answer is 5 and 6. That's the only option. So these are 2, 3, 5, 6. And that's not a 7. This is not a 5 or a 6. So that is a 2 or a 3. This is not a 5 or a 6 either, because this whole column is done with its oranges, so I might as well blue everything while I'm at it. So this is not a 2 or a 3. It's a 5 or a 6. This column has all of its oranges, so I can blue that, which then makes this the 4. These aren't 4, so these are orange. This is not 4. At least so far. This has been much smoother for the sort of like the back half of it than the first one was. I have all of the oranges in this column, so these are blue. So this has to be orange because these sum to at most 10. So this has to be at least 5, so it's orange. Let's see. All right. So if this is a 5 or a 6, this is never a 2. Let's just do the easy thing. So these are only 0 or 1. Does row 7, column 4 have to be orange? Yes, it does. Thank you, Nordy, and welcome. That is the sort of thing that I might have hoped to notice, but I did not. Oh, I don't know why I got rid of the 5 corner mark. The 5 corner mark is still there. So yeah, one of these two is the 3. So I think Isabella wants me to fill in that these are from 0, 1, 2, 3. Let's see, there's a 6, 7, 8, 9 quad in column 9. Ah, yes, there is. Thank you, Kajito. So that makes that a 5. Makes these not 5. Oh, right. There are no 4s. Got it. Okay. Jaleb is really sweet with the Sudoku spots. These 4s look at all of these blue cells. And so therefore these blue cells are exactly a 0, 1, 2, 3 quad, which I know someone else was also trying to tell me, but I did not understand it until it was pointed out that it was a Sudoku thing and not a math thing. So therefore this has to be a 9, because these only sum to 6. So that's a 9. Gets rid of some 9 there, some 9s there. Right, and so Afraid Not points out now I have a 6, 7, 8, 9 quad in this column, and so therefore that's a 5. And so that's a 6. And now 5 is actually only 1 away, or only 5 away from 0, so that's a double 0. That's a 1. This is not as 6 as it was before. Sorry, these are not 1 is what I meant to say. This is not 0. One of these two is 1. That's not 0. That's not 0. That's not 0. These aren't 0. This is not 6. So the only orange left in this column is a 5. It's going to go on the betting tree and make me very unhappy. That is my prediction. Let's see. I was trying to decide if I thought there could be an orange digit in here, but I think there can definitely be an orange digit in there. I mean, I can fill in the values, I suppose, for what's left in this column, because there's not much. We need a 1, 2, 3, and a 5 is what we need in this column. So I can actually just fill those in. Good spot from Jaleb. There's a 0 in column 10 that can only be in this cage, and so therefore this is never a 0. Oh, sorry, that was Chris. Sorry, I misread it. I can just fill in that this is 1, 2, 3. Can this... It can't be double orange, surely. Because the minimum sum of these 3 is 3, and double orange... Yeah, these just barely can't be double orange. So there is a blue in one of these 2 cells, at least. They could both be blue. There's a blue in here, and there's a bunch of blues over there. So if this were blue, it would be the last blue for the row. Let's see. So why is the tree not 2? What am I seeing? Oh, the row, right. The row has a 2, Todd points out there, so that's not a 2. Crispy asks how many blues this cage needs to have. And so if it had 3 oranges, then those would add up to at least 5, 6, 7. Yeah, it can. 5, 6, 7, 0, 1 adds to less than or equal to 19 is the answer. So yes, there can be only 2 blues in this cage, as long as one of the blues is a 0. And the rest are 5, 6, 7, which I don't think I can disprove. I can fill out that I know that this is 0, 1, 2. Strangely, I know this cell can't be a 4 because it sees everywhere for 4 in row 3. So the 4 in this row is actually quite restricted. Can only go in those cells. Can be 3, 2. Oh, it can be 3, 2. Right, sorry. I keep doing the thing where I assume there's only 3 of these things, but there's not only 3. Afraid Not asks, where does this digit show up in row 10? Sorry, in row 9, and the answer is the only place this digit can show up is over here, which lets us pick a pencil mark off of that. That can't be a 7 anymore. We might be able to leverage that for more. I don't know. Oh, right, this can be a 4. Never mind. My claim was wrong about 4s. This can't be a 0 because there's a 0, 1 pair in the column. Column 9, 10, Jovi wing on 7s. Right, okay, so here are all the digits that can be 7 in column 9 and 10. That's it. Okay, so if I just ask where does the 7 go in column 9, and where does the 7 go in column 10, these are the only places they can go, which means one of these 2 is a 7 for each pair. What on earth? Oh, this is just highlighted for no reason. One of these is a 7, so that's not a 7, and that's not a 7. So now we have a 6, 8, 9 triple in column 8. That was what that got us, because now none of these are 7. And so therefore that is a 7, an 8, and a 9, and an 8, and a 9. And so that is a 7 and a 6. And These are an 8-9 pair. This can't be a 9 anymore. That can't be a 9. That can't be a 9. That can't be a 7. These can't be 7s either. This certainly can't be a 4 anymore because that can't be a 9. So where does 7 go in column 6 now? 7 in column 6 can't go here, so the 7 in column 6 has to go in one of these two cells. Is that interesting? It's probably interesting. Yeah, okay, so the 7 in column 6 goes in one of these two cells, and the same exact thing is true of the 7 in column 5. So we actually get a little Jovi wing on 7s. But in particular, there's definitely a 7 in the less than or equal to 19 cage. And so the remaining digits need to sum to at most 12. Unfortunately, they could still include a 5, regrettably. Now, Isabella's pointing out, I certainly can't put a 9 in here with the 7. So 9 plus 7 is already 16. Wait. Could I do 9 and 7 and 0, 1, 2? Oh, I just can't even by Sudoku. I can't put a 9 in here. I don't even have to math it. There's an 8-9 pair looking at this cell. So 9 by Sudoku doesn't go in any of those places. It doesn't go there. Can the 9 go in here? And the answer is no, because the other 4 digits sum to at least 6, which is too many. So the 9 in the row does indeed go here, per Isabella. So these are not 9. So one of these now is 9, and so therefore this is not 9. So it is only 6 or 8. And we can play the same trick, More Crabs points out, with 8. I can't put 8 in the less than or equal to 13 cage either, because 8 plus 0, 1, 2, 3 is still 14. That's still too big. So 8's actually exactly here. Which is going to do a lot of damage. Okay, so that's going to be a 7 and a 5 and a 0. This is not going to be a 7. It's not going to be a 5. None of these will be zeros. That won't be a 0. That won't be a 0. This is now just a 6. And so this is just an 8. That's a 5. These aren't 8. Or 6, or 5. That's not a 5. That is an 8. These are non-8 sorts of numbers. These are non-8 sorts of numbers. This is not 0 or 5, or in the corner. Okay, so the 7's over here. Could I have the 7 and the 6? I think I could, yes. Where did I remove the wrong digit? Oh, row 10, column 4. 0, 5. Oh, I removed the 3 somehow, didn't I? It's blue, though. Da-dee-dee-da-dee-da. I'm trying to decide if I think I can put a 4 up here. Let's see. More Crab says 8 in row 1. Ah, yes, 8 in row 1. I don't know why I was somehow looking at 8 in row 7. 8 in row 1, though. 8 can't go here, so now 8 is just placed. Uh-oh, we've broken the puzzle. No, we have not broken the puzzle. We can place an 8 there. and row 1. 8 can't go here because there's an 8 looking up at it. 8 can't go in these because there's an 8 in the cage there already. So not an 8. Blues in column 4. Ah, yes, blues in column 4 are all that remain. Thank you, Isabella. And I think I still could barely put a 6 exactly there, right? If this were 6 and 7, those would sum to 13. I would just need to keep these under 6, which I could do, I think. The 14 cage. I don't think we've really looked at the 14 cage. Do you have a deep insight about the 14 cage? I am excited to hear things about the 14 cage. We know it has a 0. Let's see. These are 1, 2, 3, 4. Well, the biggest digit that can be in here is a 6. Is that interesting? Does it need to also have a 5 if it has a 6? Let's see. So what if I do 6 and no other digits? No, then I could get to 16 without any other high digits. So 6 or 5 are the high digits that can be in here. 6 and 5, but I need one of them because I can't use all of 0 through 4. It will not sum to 14. So there's a 6 or a 5 in here. And maybe both. Isabella points out, where does 2 go in row 5 is a good question. So 2 in row 5 needs to be in one of these cells. That is true. I agree. So 2 of the digits are 0 and 2. So the other 3 digits add to 12. I agree this digit's at least 3. I think I would probably take Afraid Not up on the suggestion to pencil mark the rest of this column. So we've got 0, 1, and 2. We need a 3 and a 4. We've got a 5. We need a 6. And then we've got a 7, 8, and 9. So these can only be from 3, 4, 6. Those are the only things that are left in the column. 14 cage must also contain a 1. If it doesn't contain a 1, oh, right. Just by counting 1s in the rows, there need to be 2 1s in these 2 rows, and the only places that can accommodate them are this cage and this cage. So there's definitely a 1 just by the 14. So the 14 cage has a 0, a 1, and a 2. So those 3 digits sum to 3. And so the other digits need to sum to 11. But I don't have a place for a 7, so they have to be 5 and 6. So I think if I followed my own saying there that this cage is a 0, 1, 2, 5, 6 cage for sure. And so in particular, it doesn't have any 4s in it. And it doesn't have any 3s in it either. So that's a 6. That's not a 6. That's not a 5. That is high now. I like the fact that this is a puzzle I get to color twice. The rest of this row is high now. Hey, Panthera. This is blue. This isn't a 3. And so this has to be the 5, because I needed a 5. I have a 0, 1, 2 triple in the cage, if you prefer to think about it that way. This is not a 5, and so it's blue. Da-dee-dee, da-dee-da. So the betting tree is not a 5, we have learned. 4 in row 5 is placed. 4 in row 5 is placed here. Many people in chat are telling me. So these are not 4. That gives me a 1-2 pair in the column, so therefore that's a 0. So these aren't 0. This is not a 0 or a 1 or a 2, so this is the 5 for the column. So that's not the 5, so that is blue. I have my... Oh, right. The betting tree is blue. I've known that for a while. So this is orange. Oh, I only learned that the betting tree was blue a moment ago when I learned that this was a 5. So that is the 5 for the row. Okay, we need to get to less than or equal to 19. Now that's suddenly going to be difficult because I've got a 5 and a 7. Those two add to 12. So the remaining 3 digits in the cage need to sum to 7 or less. Maybe that's still not actually all that restrictive. Okay, column 3 has all of its oranges, so let's at least blue some stuff. No, not orange some stuff. Blue some stuff. Okay, so yeah, that's all the oranges. And so in particular, the 3, 8, 9 that I blued is actually a 3. Making that orange and a 9, and a 7 and a 9, and an 8, and a 9, and an 8. So we've got that. Probably I know what the last thing in this row is. I think the last thing in this row is low. So the last thing in this column is high. The last thing in this column is high. And the last thing in this row is low. I think we have that. Okay, and so that's going to make this very interesting, because now there's actually these we know are 5, 6, 7. They have no other choices. And in fact, that one is the 7, and that's the 6. But these now sum to 15. So these sum to at most 4. That's not going to be that difficult, actually. But that's the 7 now. This is the 5. This is the 6, and the 7 and the 6. Oh. If you do the math correctly, it's much more interesting. So 5 plus 6 plus 7 is actually 18, which means these sum to at most 1, which means they have to include a 0 and a 1. And so we get to place the 0 up here. Okay, so that's much better. Thank you, chat. Let's see. So yes, we've got a 0 looking over. These are from 2, 3, 4. But they definitely contain the 4 for the row. So these are not 4. These aren't 3 while we're doing things that aren't things. As it happens, the less than or equal to 13 cage actually sums to 10. Someday. Okay, one of these is now the 4 for row 3, which means this can't be a 4 anymore, so that's a 3. So that's a 2 and a 3 and a 1 and a 4. That's a 4. And people complained when I filled this in earlier, but it was completely correct, and people need to give me more credit for how much I'm able to hold in my head at once when I randomly write something in the grid that I shouldn't. Let's see. This seems to be a 2 now. So that's a 3, which means this is definitely not a 6, it's a 9. So that's a 7 and a 6, and a 3 and a 2. Let's see, that's a 9 and an 8, and a 9 and a 7, and an 8, and a 6, and a 1. Let's see, this is a 2, a 1, a 3, a 4. This is a 0. I did not type the 0 key. This is a lovely puzzle. I really enjoyed this one. I do think, I think Math Pesto said that they believed that this was smoother than the previous one. I do think this has been much smoother than the previous one. There was not a huge downtick in my enjoyment of the puzzle when we switched from the fun part to the less fun part. So that is a good thing. So that's a 3. No, that's not a 3. Sorry, don't listen to me. That's a 0. That's a 2. That's a 0. Let's see. This is not a 0 or a 3. That's a 1. Let's do that one. That's a 1. So now this is a 2. So these are not 2. Sorry, that's not what I wanted to do. That's what I wanted to do. Oops. No! That time it highlighted the cells that were marked 1, 3. Dang you, Sven. Dang you. This is a 3. That's the thing I was missing sudokulogically. Because there was already a 2 in the cage. So that's a 2, a 1, a 3. And we get to do our betting tree last. There is no way it could be determined until now. And we discover that the betting tree is a 3. Congratulations to Bremster. Alrighty, gorgeous puzzle. I actually think this was easier than the previous one. In all the right ways. The previous one had a lot of irregular Sudoku stuff. This one had a little, but not an untoward amount. Yeah, I was thinking when it was Super Smash Boy that it was going to be harder than the previous one, but I guess it just means there's better graphics, which makes sense. But yeah, great puzzle. I really enjoyed that. And I seem to have lucked into a good betting tree by chance. Alrighty. Because last time I was unable to do this puzzle because I was streaming with Tallcat and finishing up the CTC pack, which was, by the way, tons of fun. And if you did not watch Tallcat and I go through and do all of the puzzles that were submitted for the Cracking the Cryptic 500th anniversary puzzle, I recommend go back and watch those. I think that was a lot of fun. But because I wasn't able to do this puzzle, which was the one that was leading at the time, I'm also going to do the next leading puzzle, which is by tesseralis. So I will be back with the tesseralis puzzle in just a moment after I take a short break. See you all very shortly. Alrighty, welcome back, everyone. We are back with a tesseralis puzzle. So we are doing two voted on puzzles. So this is the next most voted on puzzle. This puzzle involves Haver cells and thermos. So these are thermos. So we have to put the smallest digit on the thermo down here, and then go up by go up as we go along. So we could go 2, 5, 7, 8. And as long as we keep dreaming up 4 more numbers bigger than 8, we'll be fine. That might be a problem, though. However, every row, column, and box has a halved digit. So there's a Haver cell. So we could have, for example, and this is the example in the prompt, if this digit is halved, then it counts as a 2.5, and 2.53 is a perfectly valid thermo. Now, we also have the doubler rule for Havers, which is that each cell or each number is halved only once. So we have to keep that in mind. And yes, it is your puzzle, tesseralis. Did you want to suggest a betting tree cell? I will happily betting tree. Let's see. I will let tesseralis muse on the betting tree while I count how long these are. 1, 2, 3, 4, 5, 6, 7, 8. So normally it would be quite interesting to have a length 8 thermo. Row 7, column 1 is the answer. This is the betting tree. So place your bets now. As you place your bet, make a wish, and if you bet correctly, the wish will come true. That is my understanding of how this works. Yeah, the 1 can certainly only go. Okay, so let's think about where 1 goes in this box. 1 certainly can't go over here. And I could have a 1/2 1. I think that's okay. So I could do Haver 1, regular 1. That would be fine. So I think the 1 in this box goes in one of those cells. But I certainly can't get a 1 any more than 2 spaces along. And if I do put a 1 here, I also put a 1 there. Now here, I certainly can't put a 1 here, because I would have to also put a halved 1 here, and that's not going to work. So over in this box, we get 1s in this same L shape. And so if neither of these is a 1, then there's a 1 in here, but that seems fine to me. Oh, I can do the same trick over here, where I say, okay, here in this box, we also get this L-shaped collusion of 1s. I don't think we know anything about row 5 or about box 5, really. If you know something about box 5, by all means tell me, but I don't think I know anything about box 5. Row 2 is almost interesting, but not quite. And the high digits are going to be really tricky, because a 9 can go like way back on a thermo if it's halved. But I feel like we're almost sort of setting up for one of those like patterns that's covered by one of those like lattice patterns where you do like a mutant swordfish or whatever Jovi would call it. Okay, so there we go. Okay, so that is the question. Isabella has it. Where does this cell go in this box? And the answer is this cell always goes on the thermo. And so either this cell is halved here, in which case it shows up, because a number can't repeat on a thermo. So that means either this is halved, or its other appearance is halved. So if this is the cell that's halved, well, then this cell is halved. Otherwise, this cell is normal, and the halved one is over here. So the way I'm going to parse that out is that one of these cells that I have highlighted has to be halved, which means that these cells are all not halved. I think we're going to make yellow not halved. I like gray, maybe green. But this gray is just going to vanish the thermos, I fear. So we're not going to do the gray, or the black, or the gray. Yeah, we'll do green. I think green will work. So these can't be halved, because if these were halved, I wouldn't be able to put this digit in the box at all. Okay. I had to ask the same question about this cell. Where does this cell go in this box? And this cell, well, it has to go further. It has to go on the thermo further along. It has no choice. And so because this cell has to go on its own thermo further along, this cell has to be halved here. So we're going to make this a nice halver. So we have our first half-baked cell. So we can green all of that. And now, because this is halved here, this is not halved there. Uh-oh, did I just break the puzzle? I did something wrong. Let's go back. Because this has to show up on its own thermo. It has no choice, Sudoku logically. So this has to be halved here, because it shows up later. So this is halved. Oh, right. Okay, sorry. I think I was afraid of something for a second, but I think it's okay. This digit now shows up halved over there. So this is green. We know one of these is halved. Okay. So this digit we know shows up over there. This digit we know shows up here somewhere. Probably shows up there, but who knows? We could now good lift this thermo hilariously. But yeah, we get to repeat this trick several more times because either this cell is halved or it's halved over there, all of which tell me that these cells can't be halved. This cell shows up halved on this this thermo. So this cell can't be doubled because it's halved in this box. So this cell's not doubled. This cell shows up in this box, and so it is either halved or it shows up halved over here, which means all of these are green. Right. Isabella makes a point which applies to both of these, which is that either this is halved or the thing, or it's halved again on the thermo. Either way, these are never halved. Good spot. So I should probably start thinking about sizes. So what's the biggest this digit could be? The biggest this digit could be is 5. So this digit, therefore, is at most 5. So this is from 1, 2, 3, 4, 5. Let's fill that in. Nicholas also thought to do that as I was doing it, I see. Right. This digit is halved here, so it shows up later. Wait, sorry, I did this wrong. Sorry, I was thinking the wrong thing. This is the digit that shows up halved over here. This digit shows up normally along this side. No, sorry, this digit shows up normally, but I don't even know where. It could show up normally there or show up normally there. I probably have to think about the math of that. Let's see, J has a point. Row 3, column 8 has to be halved because you already have a halved in box 6, right? This digit is halved in box 6. Okay, good point from J. This digit we know is halved in box 6. So this digit can't appear halved over here. It has to actually appear normally over here, which means it has to be halved here. Very good. Let's see, I can green some more stuff. So there's a halved digit on here, interestingly enough. So what do I do with the fact? So the halved digit up here has to be at least a 6. So somewhere on here there's a 6, 7, 8. Oh, somehow I failed to green the rest of this row. We can definitely green the rest of the row. That's a good idea. But yeah, the digit up here that's halved is big. Yeah, this digit shows up halved in here somewhere, but I don't really know. Oh, right. That's a good point. Okay, so Jay has a great point, which is that the halving digit up here, whichever it is, it halves to at most 4.5, which means that these digits are from 1, 2, 3, 4, and of course, this one can't be a 1, this one can't be a 4. Oh, David donates $10 to Tesseralis being featured on back-to-back days by 2 icons of the community. I greatly appreciate being called an icon of the community. And we can do a donation dance. Thank you, David, from both Zach and I. We greatly appreciate your continued support of our endeavors. It means a lot to us. It really does. I really want this to be the one. Sadly, like, you'd think, oh, well, the halved one has to show up in a bulb somewhere. But the halved one could just not show up on a thermometer at all. And that's possible. Ooh, we have another donation from Glum Hippo for Tesseralis and Tesser Wonderland. Thank you very much, Glum Hippo. Woo! Woohoo! Donation dance. Thank you, Zach. Thank you, Glem Hippo. Great to have you here. And did I see you saying earlier you got your new fancy COVID shot today? That's always very exciting. Yes, I agree with people in chat who are saying they wish they could disable YouTube shortcuts. The amount of times where I accidentally hit a key and suddenly I skip to the end of my video or skip back to the beginning or whatever is just infuriating. Okay, so this digit definitely shows up on that side. This digit, I don't know where it shows up. I guess this digit has to be pretty big, doesn't it? Because this digit is at least 4 along a thermo, but it's halved. Does this digit have to be a 9? Okay, let's think about this. So the digit that's halved in this box is this. I guess here's the way to think about this. How many halvers are there on this thermo? There are 2 halvers on this thermo. And so if I just sort of skip 2 ahead, then I know this is at least 1, 2, 3, 4, 5, 6. This digit here has to be at least 6. But also, this digit needs to have at least 2 honest digits less than half of it. And so, therefore, this digit certainly needs to be at least a 6. And 6 seems like it's going to be a big stretch to me to make work. And now this digit... This digit is halved, Tristan. But 6 seems very difficult. In order for this to be a 6, I'm going to need the halved version of this to be less than 3. Well, that just can't work, right? The halved version of this could never be less than 3, right? So this can't be 6. This can't even be 6, much less 5. Because if this was 6, this is counting in as a 3. And then I would be saying that this digit, half of it, has to be less than 3. Because the only way that this could possibly be a 6 is if there's a halver over here. But there's no way that this digit could be as small as that. Because if it's as small as that, then I've just broken this box in half, right? This digit would have to be less than that one. So this cannot be a 6. 6 is too small. If this is 7, it's 3.5. Now we're in the realm where this is plausible. Is there any way that this digit's ever over here? I think there's no way that this digit actually is halved over here. I think this digit has to be halved over here. I think. Maybe not. Okay, let's think about this. So this digit needs to show up on a halver on one of these sides. I guess if this is like a... Okay, so people are claiming this can be 5, which I really don't believe, but let's try and write it out. So if this is a 5, where am I putting this digit? Because I have to put half of this digit, right? This digit, remember, has to go in box 6. So this digit, which is quite large, is halved in box 6. So I cannot put a 2.5 on this line. I cannot put a 1.5 on this line. Because this digit, just by pure Sudoku, has to be at least 6. So this can't be a 5 or a 6, because half of this digit is at least 3. And unless I put the doubler over here, which would have to be, or sorry, the halver over here, which would have to be the halver of this, I can't make this less than 7. But even when I do, I think that this is still tricky. But I do know that this is a 6, 7, 8, or 9, so I should fill that in. The way I got that this is a 6, 7, 8, or 9, by the way, again, is just to say, okay, this thermo has 2 doublers on it. Just ignore them, and then start 1, 2, 3, 4, 5, 6. This has to be at least 6. This digit... Oh, right. I don't know if this digit shows up halved or if this is the halved version. Right, okay. Now that is an excellent point by Crispy that I feel I should have seen but was just not getting. This digit is on this thermo. Unhalved. And so this digit down here has to be strictly larger than this digit. That is a beautiful argument, Crispy. I like that a lot. So this digit, owing to the fact that it appears over here somewhere, definitely can't be a 9. And so this digit now actually, because this is now only a 7 or an 8, this digit is only an 8 or a 9. Those are the only options for this digit. Very cool. And so that means this digit's at least a 7, right? No, it means this digit's at least a 7, this digit's at least a 7. It doesn't necessarily have to be the same. That one could be that 7, 8, I don't know. But we've got that. And so now, where is half of this digit in this box? Half of this digit is now not over here, because half of this digit is bigger than half of this digit. That's genius. Okay, this is a great puzzle, as I say about most tesseralis puzzles. This certainly is not doubled, or sorry, certainly not halved. So this halver is in one of these 2 cells. Okay, and so these digits are all, just to be clear, they are less than 4. So these are 1, 2, 3. These just are 1, 2, 3, because half of this is only 4. So we get a whole bunch of digits. These have to be 1, 2, 3. And we get the bunch of digits dance. Boo! Boo, boo! Woo! 1, 2, 3. Woo! Woohoo! Waha! Awesome. Okay, so great opening to get to that. These can't be halved because we know the halver is up there. These aren't 1 anymore now, and if those aren't 1, that means the 1 in this box is actually in here. I don't know why I was so excited by that. There was this earlier thought that this was probably going to be a 1 and put a 1 here, but it didn't, so does that. Okay, so this now is at least a 2, I guess. But half of 2 is only 1, so this could still be 2. I don't think we have learned a whole lot of that. So I guess I know that these digits are at least 4. I guess that's boring, given what we literally just filled in. It is interesting to note what that does here, because now we can actually good lift this thermo, because we know that this is a real thermo. So we can actually like do a real proper good lifting of this this thermo. This 789, okay, this 789 is interesting, because this 789 tells me... Well, it tells me that this can't be a 7, 8, or 9. Because if this was a 7, 8, or 9, these would all be 7, 8, 9s, and that's not going to work. So this is not a 7, 8, 9. This is a 4, 5, or 6. Oh, but it could be a 4 by virtue of being half of this. Never mind, sorry. Never mind. It's... Jay claims these two are equal. Do we really know that? Can we really not make this go 7, 8? Oh, right. I made this, I good lifted this badly, because I good lifted this thermo without realizing that there's a 7, 8 in the box. So this can't be as high as 7. Sorry, this can't be as high as 6, because if this were a 6, this would need to be 7, 8, 9, and that would break this cell. If this were 7, this would need to be 7, 8, 9, and that would break this cell. That's not going to work. So these are only from 4, 5, 6, actually. Oh, right. Okay, so, sorry, Jay has this exactly correct, and it's beautiful. Both of these two digits need to go into this box on this thermo. And the point is, the two of them, together with this, make a 7, 8, 9 triple. I know that this digit isn't that digit, because it's a thermo, so this digit is that digit. So these two we can black flash. These are the same digit. That is very cool. So if half of this... Okay, so More Crabs is pointing out we know where half of this goes in this column. If half of this was here, does that break? So if, let's say this is a 9 and a 7 to give us the most latitude, we could put... This would be a 4.5. No, that's not going to work. Oh, column 7. Column 7. Oh, just this digit in column 7. Where does this digit go in column 7? It only goes there. Okay, never mind. So these two we can gray flash. Sorry, I misunderstood what was being said. So that gives us a 7, 8, 9 triple in the box. So that's huge. So that 7, 8, 9 triple in the box makes that a 6 and a 5 and a 4. More digits. So that is very cool. And so these digits are, just for the record, 1, 2, 3. These are 6, 7, 8, 9. So where does 6 go in this box? It definitely goes over here. And 6 is bigger than half of this digit. So half of this digit has to go here. And then the 6 has to go here. And so this is the gray flash 8, 9. Is how this works. Very cool. I'm briefly contemplating to see if any combination of these things is going to break, but I don't think it does. But it's possible there's Sudoku. Oh, this is the wrong shade of gray. Thank you. It was supposed to be the darker shade of gray. Column 8 has a 1, 2, 3 triple. Matt Pesto points out. Very good observation. I know that these are not from 6, 7, 8, 9 because I have a 6, 7, 8, 9 quad. So these are from 1, 2, 3, 4, 5. And then I somehow had a 6 instead of 2 in there or whatever. Okay. So now's where we come back here. Because remember, the digit on this haver over here, we said, had to be at least as big as 6, right? We could only have a 6 if we put it here, though. So actually, the digit that's on the haver here is actually a 7, 8, 9. So the last 7, 8, 9 haver is over here. Because I can't have a 5 or a 6 here. So, this cell is green. That is gorgeous. Oh my god. That is my favorite step in a Sudoku puzzle in a long time. This cell can't be the haver, because we know the haver in this box is a 7, 8, or 9. But it's the 7, 8, or 9 that's not that 7, 8, or 9 or that 7, 8, or 9. Well, that's that 7, 8, or 9. So that 7, 8, or 9 can't go here because it's already in the row. Wow. Brilliant. So that is the last 7, 8, 9 of the havers. And so this digit here actually has to be less than half of 9. So it has to be at most 4. So this is a 3 or 4, I believe. This could never be a 4 anymore, because now this needs to be bigger than it. This could never be a 3 now, because of that same thing. This needs to be bigger than it, and I couldn't put it here anymore. I can green row 1. That is a good point. I briefly was afraid we'd forgotten to make a betting tree, but no, we did remember a betting tree. We put it there. So this digit... okay, there we go. Here's the point. This digit... Oh, row 4, too. Hey, why not? This digit is halved in one of these two cells. We know that, because this digit has to go in this box somewhere. It's halved. But now this digit is at most 6. And so it halved is at most 3. Although I guess I could just put it here, and that doesn't really tell me a whole lot, because this wants to be small. Maybe that's not exciting anymore. Okay, so, what digit is halved here? The digit that's halved here is a 6, because the 7, 8, and 9 are already halved elsewhere. So the 6 is definitely in one of those two cells, and it's halved. So the 6 haver is now gone. So now 6 is dead, as far as halving goes, because 6 is halved in this box. So now 5 is the number that is the smallest number, or sorry, the largest number we can have. And so when I have this number... Oh, sorry, I don't know if I'm having... Oh, I do know if I'm having this number or not, don't I? Because if this number is halved, then it shows up down here. Yeah, this is exactly... I was explaining exactly what J40 is asking about. If this number is halved, then it shows up down here unhalved. But then it's at most a 5. And there's no way I put a 5 haver even at the end of this, which would be like a 2.5. Sorry. This would be at most 5, which would be halved, which would be 2.5. And then I can't put the actual 5 down here because I don't have 3 digits I can put over here. The whole upshot of this is that this is not halved. And so this digit shows up halved over here in this box. So these are not halved, is the point. So that's not halved, because one of these two is halved. Okay, let's see. Screaming Ice Cube wants to know if row 3, column 2 can be higher than 5. It cannot be higher than 5. It is at most 5. So this digit is a 1, 2, 3, or 5. It's not a 1. I can go at least that far. I don't believe it can possibly be a 2. Can't be a 2. I think it can just... Can it get away with being a 3 is the question. And I think the answer is it can't get away with being a 3 because of these pencil-marked 1s. So there are 2 honest digits that are less than this digit in this box, plus the 1. So there are 3 honest digits less than this digit in this box. So this digit can't be a 3. It has to be a 5. And so there is a 5 haver over here. So now the largest digit we can have is 4. So this is a 2, 3, or 4, by the way. It's not the 1. It's probably a good time to ask questions like, where are we having the 1? I guess we can have the 1 here, or maybe even up here. But we've halved the 5 now. Okay, so this digit is less than 5. So this digit... But on the other hand, this digit is at least a 1. So this is at least 2, 2.5, 3. So this digit has to be a 4, is the only thing it can be, because this is at least... at least 2.5, but it can't be 3. So what digit goes here, by the way, I guess is a good question. So what is this digit if it's not the 5? If this is not the halved 5, I guess then this digit is a 3, right? Because it has to be bigger than 5 halves, because the 5 will be there. So this digit's always a 3 or a 5, because either the 5 is here, in which case it's a 5, or this digit is less than... Wait, 5 halves is... 3 is not less than 5... Right, sorry. Sorry, I'm articulating this poorly. If this digit is not a 5, this digit is a 5, so it's a 2.5. So this digit has to be more than 2.5 and less than 4. And so it'd have to be a 3. So this cell's always 3 or 5. On the other hand, if this is the 5, this digit has to be less than 2.5, but it can't be 1. So this would have to be 2. So this digit's always 2 or 5. And we're really close to building our own, I don't even know what. We're trying our best to build our own something out of something. I had assumed it was a drugs reference, which was why I wasn't emphasizing it. But perhaps not, or perhaps that is why it is. Let's see. Let's see. So we've got the 5, 6, 7, 8, 9 halved. Okay, so do I know anything at all about these digits? I guess I know the 4 is in one of these two cells while I'm at it. And I know that 789 is in one of these cells, because that 789 is that 789. I guess I can get the other flash of gray, just so that we remember that. 5, 4. Like that number has to show up in here somewhere. Row 4, column 3 is a 6, I am being told. I guess I can good lift this, so let's good lift this. 6, 7, 8. Ah, right. This cannot be a 7, because then that would break the 7, 8, 9. So yeah, so this is always a 6. And so this is a 7 or 8, and this is an 8 or a 9. And I know which 8, 9 this is. This is that 8, 9, because it sees the other two. Gorgeous. Okay, so this is that 8, 9. So this is dark gray. And so this is black. So our attempt to color the world is slowly succeeding. Being told this place is one of those. Ah, right. Okay, so yes. So dark gray in box 1 now has to go here. Very nice. I wasn't even looking at that dark gray, but that dark gray indeed is there. So that is an 8 or a 9. So there's an 8 or 9 down here. So I guess I could just fill in these digits. These are from 1, 2, 3, 4, 5. That one's not a 5. Oh. Or a 4. But these can be 4. I don't know why I didn't hit 4. I almost have my quintuple. These are... this is a 4 now, because I've got a 1, 2, 3 triple. Right, I've got a 1, 2, 3 triple, so this is a 4. And so these aren't 4. And then the 6 and the black 7, 8, 9 are up here. Ah, right. And then multiple people in chat see this at once. This tells me what light gray is. Because now, light gray has to be 9, because half of light gray is bigger than 4. So light gray is 9. And so that tells me that dark gray is 8, and black is 7. Dark gray is 8. It's 8. These are not 8 or 9. They are 6 and 7. Beautiful. This is not an 8, so... so those aren't 8 either. This is also an 8. That's a 7. I was terrible at identifying all of the places to fill these things in, but I think we now are closer to at least to having all of them filled in. Yes, new feature is that digits glow red if you want them to when they are seen by Sudoku. Yeah, you go away and get distracted by this whole having a kid thing, and all kinds of stuff happens. 4, 5, and 9. Oh, did Peter get a feature today? Congratulations. Let's see. So this is only a 5 or a 9, for whatever that's worth. It does not seem to mean a lot to me. Okay, what digit am I doubling here? Well, here's the thing. It's a 1, 2, or a 3. And so the digit I'm doubling here, together with these digits, makes a 1, 2, 3 triple. Because the only digits I have left to double or sorry, left to have are 1, 2, 3, and 4. Well, this one's not a 4, so it's a 1, 2, or a 3, which gives me a virtual triple, which then means this digit is actually quite limited. It's not 1, 2, 3, 4, 5, 6. It's only 7 or 8. I was hoping that would do more because I felt smart about it, but it did not. Yeah, one of those is 1, 2, 3. One of these is 1, 2, 3. Oh, sorry. One of these is 1, 2, 3, 4. One of these is 1, 2, 3, 4. Yeah, way to go. That is quite a nice string there. I know that there is a 7 up here. If I put the haver here, I have to put a 1 here. Oh, that's a good point. Okay, so beautiful point from Jay. This digit, remember, is halved in this box. So this digit's not a 1. So this is only from 2, 3, 4. I was thinking that was going to tell me that this wasn't a 1, but it does not. So the 1 is not halved in this box. The 1 is not halved in this box. The 1's not halved in this box. So the 1 actually can only be halved in one of those two cells or one of these two cells, right? I think that's true. I think we're really narrowing in on the places where the 1 haver can be, because now it can't be this one. What's wrong with it being 2, Ambrose? Is there some row 7, column 4 is limited? Oh, right. Okay, yeah, sorry. I had to think about the fact that this cell's actually on a thermo. Right. There still have to be at least 2 real numbers that are lower than this. So this could never be a 2. And if this is a 3, then it makes these cells a 1, 2, 3 triple. Actually, wait, if this is a 4... What is it? Okay, so if this is a 4... that's the point. Whether this is a 3 or a 4, I need a 1 on this thermo or it doesn't work. Because if this is a 3, then I need to put a 1 in. Then I need to put 2 digits less than 3 on here. They have to be 1 and 2. If this is a 4, I need to put 2 digits less than 4 on here, but I also need to put a 4 on there, and the 4 counts as a 2. So I can't use a 2. So I only have 1 and 3. So there's always a 1. It goes there. It's not the digit that's doubled. That is the digit that's doubled. And therefore, this is not the digit that's doubled. So this is the digit that's doubled, and it's the 6. These are not 1. That's cool. This has been a great puzzle. Start to finish so far. I guess I can't really say start to finish so far. That's not really a thing. This is a 3 or a 4. And it's that 3 or 4 for whatever it's worth. Probably should give it a red flash just to be safe. So So yes, this cell can only be 2 or 3 because it's now bigger than this. So yeah, this is always a 2 or a 3, as many people in chat are pointing out. And the other of 2, 3, and 4 is in here, but I don't know if I could do anything with that as of yet. Weird triple in row 7, columns 2 and 4, and row 8, column 4. That is a weird triple, but it's true. These 3 digits are 2, 3, and 4, which means that this digit's never a 2, 3, or a 4. So how do we know that? These two are definitely different. This one is different from that one because they're in the same box. This one's different from that one because they're both doublers. So these digits are not from 1, 2, 3, 4. They are at least 5, 6, 7, and they're not 8, and they could be 9. Except this one, if you look at it, it's actually a bit more restricted than that because it can't be a 9. So say 5, 6, or a 7. If this is a 7, this goes 8 or 9. So minimum, this is 6 and 7. Maximum, this is 8 and 9. So that could be 8 and 7, I think, is the way that works. If I did that correctly. Yes, the weird triples is what I really like about all of these sorts of things. Right. Okay. So Jay spots a really interesting thing. If this is a 2, this is a 3. Wait, no, isn't that okay? If this is a 2, that's a 3, that's a 4, but it's a 2. No, I think that's okay. Oh, cannot be 3. Cannot be 3. If this is a 3, then that's the 2 and that's the 4, and that does not work because these can't be 2 and 4. Because one of these is a 2 in terms of value. Right. Not a 3. Okay, got it. So one of these 2 digits is a 3, for whatever that's worth. Alrighty. Somehow I have to break into this box at some point and realize that I know something about the these things. What's wrong with this being 4, Nicholas? Looks to me like 4, 3, 2, 3 seems fine. I'm wondering if I'm supposed to ask where this digit is doubled. Or sorry, halved. because it's not halved there. It's not halved there. So this digit is definitely halved. I guess no, it's not halved over there because it's the 5 that's halved over there. So this digit is definitely halved either here or in this box. Which is, I feel, interesting. I probably can frame this more concisely by asking about the right digit. There's so many little, like, linking pieces around all of these things. Let's see. How did I get this random 7, 8 here? Oh, right, because of the virtual triple. Right, one of these is a 1, 2, or a 3. I could ask where this digit goes in this box. I know it does not go here, so I know it goes in one of those two places, but neither of those things seems to quite help me either. Let's see, 1 in this box can't go there for sure, so 1 goes in this little swoop, but that doesn't seem super useful. The other digit here is a 7, 8, or a 9. Is there a reason it can't go there? Ah, the other digit here is a 7 or an 8. So is there a reason this cell can't be the other 7, 8? Would that muck up this column somehow? I don't think so. Let's see. There's an 8 in this row somewhere by Sudoku. It's probably not in the bulb. It would definitely have to be halved, and it can't be. So there's an 8 in one of those 2 cells. Okay, there we go. That's smart. So Jay points out this digit shows up in this box over here. So this digit is larger than half of... Okay, I think we have to go through both of the cases again to understand this, but it's true, this 2, 3 is over down there in this box, and that's going to be interesting. We just have to go through the cases. Oh, right. Wait. Okay, sorry, I've got a... So this, it sounds like this is a case argument. If this is a 2, then these are a 2 and a 3, and they both go here. And then that's the point, is then there's no 5 in here. Right. Because one of these has to be a 5. Or, I suppose, maybe easier, this is a pair with the 5. So once you realize that this is a pair with the 5, and you ask where this goes, it only goes there. So this is the 4, whichever way you want to parse it. So now this can't be a 2 anymore, so this is the halved 5. So this is now an unhalved 3. Very cool. So this is green. This is not 5. This is not 4. So now, because of that argument, this is a 3. Because of that, so this is a 3, because it goes there. So this is not a 3. And so now the 3 is not doubled here. And the 3 is not doubled here. So where is 3 doubled? Or halved? Where is 3 halved? 3 is not halved. Let's just check them off. Not this box. 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 So 3 is halved here. So this is a 3. Is the punchline there. So, so we now have 3 doubled. So we now only need 2 doubled and 1 doubled. So 2 and 1 need to be doubled. So 2 is not doubled here. So 2 has to be doubled up here. Oh, I already have a doubled 4. That would have been the smart way to do it. Somehow I saw immediately that 3 wasn't going to be able to be doubled anywhere, and then I went with that. 2 has to be doubled up in this box. So this is not a 2, it's a 1. So that's a 2. Let's see. We've got assorted shenaniganery with Sudoku. This is not a 3. That's not a 3. That's not a 2. So yeah, so there's a 2 here. There's a 1 here, because I need a 1 halved. The 1 halved has to go there, which means that's not a 1. So we finally resolved the 1 pencil mark that we started the puzzle with. So these digits are a 2, which goes there, and a 9, which goes there. So that's not a 9. This row needs 4, 5, 6, 7, 8, 9. 4, 6, and 9 is the answer. This row needs, let's see, we need a 2. We've got a 3, 4. We need a 5. We've got a 6. We need a 7. And we've got an 8, and we need a 9. So that's not the 2. Well, this is certainly not a 9. More Crabs has a cool Sudoku point, which is that these 2 cells are the only places for 1 and 3 in their row, so they can't be a 5. Let's see, what are these digits? I should fill this in. These are 2, 7, and 8. These are, that is not a 2. These are 1, 2, 3, 4, 5, 6, 7, 8, 9. This is not 1, 3. This is not a 3. Yeah, the 2 doublers not being able to be in the same column is a key thing here. Let's see. This row I have not filled in. I probably should fill in this row. That'll probably help. This row needs a 1, 2, 3, 4, 5, 6, 7, 8. Well, this is certainly not a 1. This is certainly not an 8. Let's see. If this is not the 1, then that's the 1. Oh, we have a 1-3 pair in column 9, a few people point out, so we can go ahead and do a little bit of Sudoku. It's not a 1, that's not a 3. So those are a 4-5 pair. That's not a 2. Let's see. If people really want to fill in things, I will not complain. 2, 3, 4, 5, 6. No, not 6, 7, 8, or 9. Yep, these are 1, 3, 4, 5. That is not a 1 or a 3. It is a 4 or a 5. That is not a 3. Let's see. Let's see, that places 2 in column 6. So if I try and make this 2, it makes this a 1. I don't immediately see it. I also don't see the 4 in column 5 that is being suggested. Okay. That's the point. Okay, got it. If this is a 2, it makes that a 1, which doesn't work. Because, yeah, that's the point. This being a 2 would make that a 1, and that doesn't work because of the way doublers work. If this is a 2, then it makes that the doubler, but then this is a 1, and that's the doubler as well. So the point is that can't be a 2. So this is at least 5 or 7, so then that makes that an 8. So that's a 7. I like that. It took me a bit to see, but I like it. 7. Over there. This is not an 8. Right. In row 4 now, there's only one place for 2, is the point. So now that is the 2. So now this is the doubler, and that's the doubler. Sorry, haver. And so this is the 1 and the 2 and the 8. These are not 1. That's not 1. Let's see. And so now we should have a good life out for ourselves. So those aren't 8 anymore, apparently. Oh, did I... Why did these become gray? I don't know. This is not gray. It's green. This is not gray. It's green. The confusing thing is it is gray, because this is actually like that shade of gray. My 9s are that shade of gray. Let's see, 4 in box 8. Oh, the 4. Okay, I need to pencil mark the 4 in box 8. Sneaky, sneaky. So the 4 in box 8 is in one of these, so this can't be a 4. So that's a 5 and a 7 and a 9. So it's light gray. So these are a 4-6 pair. So that's a 9 and a 4 and a 5 and a 5 and a 5. Third time's the charm. It's light gray. These are not 5 or 7. That is not a 5. And this is a 6. This is now a 4, and a 5, and a 6, and a 7, and a 5, and a 9, and a 6, and a 9, and a 7, and a 3, and a 4, and a 1, and a 9, and a 3, and a 1, and a 3, and a 2, and a 1, and a 5, and a 3, and a 1, and a 4, and a 5, and a 4. Let's see. And no, not a 1. 2, 3, 4, 5, 6, 7, and an 8. These two are 7 and 8, which go in that order. These two are 2 and 6. Okay, now we've got to be sure we do all of our coloring. So 7s are all supposed to be black, including the mysterious as of yet undone 7. 8s are supposed to be medium gray. And 9s are supposed to be light gray. And that actually reveals that the bedding tree has betrayed us, because the bedding tree is supposed to be light gray. So don't look ahead too much. You might figure out what it is. So that is a 6 and a 7, and the bedding tree works out to be the hidden 9. Excellent. That was very fun. I really liked the deduction about this not being a doubler cell. That was my favorite. Like I said, that was my favorite moment in a Sudoku puzzle in a long time. Alrighty. I am going to take a quick break, and we'll be back with another puzzle after this one. Alrighty, welcome back, everyone. Sorry, that took a moment. I had to reply to an email about what kind of pens I wanted for the math office to have. The fascinating lives of a professor. Alrighty, so here we have a region sum lines puzzle. So in a region sum lines puzzle, the blue lines have the property that each box they pass through, the digits in that box have the same sum. So I usually just do this by coloring some stuff. It won't help if I color them the same color. So the sum of the yellow digits, the sum of the green digits, and the sum of the blue digits are all the same. And the same goes for every region sum line. But each region sum line could have a different sum. Okay. And the black dot digits have a ratio of 1 to 2. So I believe the break-in is going to be that we're going to fill in these cells. And all of these cells, I claim, have to be a multiple of 3. And why do they have to be a multiple of 3? It's because this sum, and this sum are equal, so I know these sum to a multiple of 3. But the whole row also sums to a multiple of 3, and so the difference must itself be a multiple of 3. So this is 3, 6, 9, and all around the corners we get these 3, 6, 9s. Now, spoiler, you are not allowed to put 9 on a black dot, and so this is a digit that has a ratio of 1 to 2 with a 3 or a 6, so it itself has to be a 3 or a 6. And that gets us our first digit, which is a 9. We get to bring out Zach early for a little dancing action. Woo! Waha! Wee! Waha! Waha! Thank you, Zach. Thank you very much. Much appreciated. So, weirdly, these two digits sum to the same thing as that digit. These digits I now know are from 1, 2, 4, 8. Actually, these two digits I also know are from 1, 2, 4, 8. This is not a 9, so these digits I also know are from 1, 2, 4, 8. And the way that I know that is because the only way to make a black dot that does not involve a 1, 2, 4, 8 is to use 3, 6. And we have a 3, 6 there, so that blocks off the ability for these to be as such. Okay. Let us... So, I guess it's worth asking, what is the sum that I'm going for? So the sum I'm going for is 45 less 3 or 6 divided by 3. So 45 minus 3 is 42. Divided by 3 is 14. So the sum I'm looking for is either 14, or it is 45 minus 6 divided by 3, which would be 13. So the sum is 13 or 14. In particular, this can never be 3. Because if my sum is 14 or 15... 14 or 13, I can't make 10 with that. So this is always a 6 and a 3. Oh yeah, we need a betting tree. This looks like a row 5, column 5 is the betting tree kind of puzzle, but if Olima would like to recommend a different betting tree, I'm happy to move the betting tree. But now, as soon as I know that that's a 3, I now know that the total is 14. I did not use that all region sum lines have the same sum. I do not believe. I just used the fact that these 3 were the same to Nell there. So that is an 8 in order to make this sum to 14 like it's supposed to. So these need to be 1, 4. This is cute. These need to be 1, 4 because they need to add to 5. And the 3's already gone. And so these need to be the rest of the stuff. 2, 3, 4, 5, 6, 7, 8, 9. These are 2, 5, and 7. Okay. This is not a 3. Okay. So now we can look at this collection. So here we need our sum to be 45 minus 9 divided by 3. So that's 12. So I need to get a sum of 12. So I can't make this 1, 2, because then I'd need a 9 in order to get to 12. In fact, actually, I need the 1, 2 here because I can... No, sorry, that's wrong. Sorry. The total is 12. It is true I can't make these 1, 2, because that would have to be a 9, so that's not a 1. So there's a 4 there. Oh, 4, 8 is already 12, so it can't be 4, 8 either. So it actually is 2, 4. Because I'd need a 0, and this is not 2 puzzles ago when we had zeros. I'm still going for 12, so therefore this is a 6. So that's a 3. These are 12 without being 3, 9 or 4, 8, so they are 5, 7. And so these are the other ones. These are 1, 8 to finish up that. In this row, because we have a 3 outie, my sum is again 14. Let's see. So if it's 14, I can't put a 1 on this for sure. And so I either do 2... Oh, it's funny. I either do 2, 4 with an 8, or I do 4, 8 with a 2. So this is also a 2 or an 8, always. Because 2, 4, and 8 do sum to 14. Cute. Okay. So now these sum to 14 as 2 digits without using an 8 and a 4. So they're either 5, 9, or 6. Sorry, 5, 9. Wait, those are just the only ways. This just has to be 5, 9. There's no other way. Because the 8 is gone. So... Wait, sorry. The ways to make 14, I said the wrong thing, are 5, 9, and 6, 8. And so we have that done. Okay. And so the 8 is going here. I don't know what the comment about the 8 in box 3 is, but we'll go with it. So that 5, 9 makes that a 6. I suspect I will find out once I miss something later. We're going to 14, so I need these two to add to 8, so they have to be 1, 7. So in this column... Hey, Sonic! In this column, my sum is 13. So there could never be a 1 here because my 13 would not work. So I'm either 2, 4 with a 7, or I'm 4, 8 with a 1. This is always a 1 or a 7, funnily enough. Again, I'm going for 14, though. No, sorry, not 14. I'm going for 13. So it's not 6, 7. It's not 4, 9, because there's definitely a 4 here. And so if it's not 6, 7, or 4, 9, then it has to be the in-betweeny one, which is it has to be 5, 8. Which means there's no 8 here. Which means that this 2, 4 pair adds to 6, so I need a 7 to make up the difference. And so now, these are a 1 and an 8. No, 1 and a 9. These are a 1 and a 9 to get to 13, because that's right, 13 was my goal, was to get to 13. Okay. So, quick scan for any of these boxes where this sum is forced to be large. Here it's at least 6, but that's not super exciting. Here it's really not restricted at all. Here it's at least 6, but that's not super exciting. I guess I'll fill in the ones where it has to be at least 6, because the minimum digits that are missing here are 2 and 4. So this is at least 6, and likewise that's true here. So these are from 6, 7, 8, 9. That one's not an 8 because there's an 8 in the box. That one's not a 7 because there's a 7 in the box. So we've got that. Is it possible that there's no way to make 9? Or one of these things. Let's see, 6. If this were a 6, this could be 2, 4. That's fine. If this were a 7, it could not be 1, 6. Oh, it could be 2, 5. But it couldn't be 3, 4. Okay. And if this were a 9, It couldn't be 1, 8. So there's always a 2 on this line? Is that what I'm learning here? Not 2, 5. Oh, I have a 5, 9 pair, right? Okay, so there's no way to make 7, right? 1, 6 is out. 2, 5 is out because there actually is a 5 in the box if I look closely. Right, this could never be a 7. So if this is a 6, this is 2, 4. If this is a 9, then this is 2, 7. So these are from 2, 4, 7. 9, 8, 7, 6, which means the 6 in this box is down here somewhere. Yeah, there's always a 2. That's a true thing. So there's a 2 over here. If this is not a 2, then these sum to at least 7. That's not so exciting, I don't think. But this one I can probably also investigate. So 6, 2, 4 works. 8... No, 8 does not work. I cannot do 1, 7, 2, 6, or 3, 5. So this is never an 8. 9 could not be... It could be 2, 7, right? So I think this is also 2, 4, 7. For exactly the same reason the above one was. Sorry, 2, 4, 7, I believe. Oh, it could be 4, 5. Oh, you're right. Sorry, never mind. Sorry, it could be 4, 5. I don't know how I ignored it being 4, 5. But I think you're right. It could be a 4, 5. But we do have these 6, 9s here floating around. Let's see. Liam suggests I look at row 4, column 2. So at least there's no 1 in here. So it's at least 5, and it's not 6 or 7. Could it really be 5? I guess I should ask. Yeah, 2, 3 is fine. So 5 is fine. It's not 6 or 7. And it could at least in principle be 8 or 9. Let's see. Do any of those magically not work? I can't do 2, 6 or 1, 7 or 3, 5. So 8 does not work. 9 with 1, 8, 2, 7, 3, 6, 4, 5. 9 doesn't actually work either. Because 9 in here doesn't have a way to work. I can't do 1, 8. I can't do 2, 7. I can't do 3, 6. And I can't do 4, 5. So actually this is a 5. And that means that these are 2 and 3 in that order, which is very helpful. And also probably would have been good to look at before I looked at the rest of the puzzle, but what are you going to do? All right, so now what are these 2 digits? These are let's see, we've got 1, 2, 3, they're 4 and a 9. Yeah, these are a 4, 9 pair. So if this is a 6, then there's a 4 over here. Otherwise, this is a 9. I feel like there's a weird virtual thing going on between these, but maybe I'm thinking about it too hard. I mean, I guess the thing is these cells are never 9. Maybe that's the point. Let's see. Virtual 4-9 pair. There really is a virtual 4-9 pair. That's correct. There's always a 4 or a 9 over here. So there's a virtual 4-9 pair, but I don't think it's interesting at all. Let's see. I do feel tempted to start pencil marking in ways that will would even make Mark blush in this puzzle. Because of the whole 4-5 thing here is very irksome. Okay. Good point from Ambrose and Jay. Where does 9 go in this box? Exactly the same place the 8 does. So this becomes an 8-9 pair, which we are very happy to see. And so now these digits are a 1, a 3, and a 6. That one's not a 6. So my total is in that collection of stuff. This is mirrored over here. So this is also 1, 3, or 6. Unfortunately, I think any of those are all fair game. But the 1 does point up, as Ambrose says. So that is a 7 and a 1. So this pair of digits, 1, 2, 3, 4, 5, 6, 7. These are just a 4-7 pair. And these are 2, 3, 4, 5, 6, 7, 8, 9. Yep. These are a 2-5 pair. So we're either 6 with 2-4, or 9 with 2-7, or 5-4. It's obnoxious that there are still options after having this many things filled into the grid. That does not feel correct. Let's see. Yes, it is flummoxing. So let's see. 3 in this box, I guess I know is in one of these cells. Do I need to work out what I'm leaving out based on these options? So I'm always leaving out a 6, but then I'm also leaving out a 4 or a 7. Doesn't sound interesting to me. This digit's always at least 4, but it's not 4. It seems... Okay, so this is a 4. It's not 4, though. 5, 6, not 6, because there's a 6 looking at it. 7, 8, 9. Okay, so this can only be 5, 7, or 9. Maybe I should look at this. Okay, this can't be 5, actually, because the 2-4 pair breaks both ways to make 5. So this is actually a 7 or a 9. And it can't be a 7 either. 7, both of the ways are broken. Or sorry, all 3 of the ways are broken. Can't be 1, 6, 2, 5, or 3, 4. So it is a 9. There we go. So now that is great. Okay, we're moving on up in the world. So 9 could be 1, 8, but not 2, 7, 3, 6, or 4, 5. So this is 1, 8, which is fantastic. Let's see. This is at least 5 now. Maybe I should just keep filling in things that are at least 5. This could be 5, I think. It can't be 6 or 7 or 8, and it could be 9. So I think this is 5 or 9. Can this really be... If this is 5, it has to be 2, 3 exactly. If this is 9, it's not 1, 8, 2, 7. It would have to be 3, 6 exactly. Okay, interesting. Medi points out that tells us where the 8 is in this box, because I can't ever put an 8 on this line, no matter what combination I make it. So the 8 on this line always goes here. That's a very good spot for Medi. So that's always a 1 and an 8. Like that, which resolves that that's a 9 and a 3. Removes 3 as an option from those, makes that an 8. So now these need to add to 12 without being double 6 or 4, 8. Or 3, 9, so they have to be 5, 7. Don't know that it does very much. This has now become a 4 and a 1. A 2 and a 4.
The 1 and 3 in box 2 are done, because I need a 1 and a 3, and so that's the 1 and the 3. So now that's a 6 and a 1. I see what the betting tree is, but don't tell anyone. So this is now a 9 and a 1 and a 9. And annoyingly, the 9 is the one that works both ways. So this could still be a 5-4 or a 2-7. The 9 is oh no, sorry, I was going to place a 9 there. The 9 is not placed there. So that is an 8 and a 1, and a 5 and an 8, and a 7 and a 5. These are a 6 and a 7. Don't think I know the order on that 6 and 7 just yet. Let's see. This seems to not be a 5. That seems not to be a 7. 2 in box 9 is on the line. Ah, yes, beautiful. Okay, so Carl points out this 2 pushes a 2 onto this line. But now this can't be a 9 anymore because it would need to be 2, 7, and the 7's over there. So this is 9. Sorry. So this is not 9, so it is 5, and these are 2 and 3. So that is a 9 and a 5. I need to put a 6 in this column. It only goes there, so that is a 6 and a 7. I need to put a 7 in this column now to finish it off. These are an 8 and a something. An 8 and a 6, so they go in that order. These two digits are a 3, which cannot go there, so that's the 3, because this can't be 1, 2, because the 2 in the box. And now this is the mystery digit. It is a 9. This is a 9. So now I need to make these two add to 9. They look like they could be 1, 8, but they can't be 2, 7, 3, 6, or 4, 5, so they are 1, 8. They're 1, 8 in that order. That is not 8. So we have that. These digits are a 3 and something. There's a 3, but the 3 is resolved. That will maybe help. 2 and 3. 5 and 4 and 2 and 7. That did help. And 5 and 7. So what is this digit? 2, 3. It is a 4, which makes that a 2 and a 4 and an 8. And a 5. And a not 5. Exquisite, exquisite. Okay. These digits include a 1, which goes there. Let's see. They include a 2 and a 4. And also a 7, none of which seems resolved. These digits include a 2, 3, 4, 5, 6, 7, 8, and 9. Okay, well, that one's the 9, I have learned by pencil marking these aggressively. So that's a 2, 4 pair. So this isn't a 2, and so it's an 8. So these two are a 2, a 4, and something else. I should remember, but I don't. A 2, 4, and 3. So this can apparently only be 2. A 7 and a 2. And a 4, and a 3, and a 2 and a 4, and a 2 and a 4. This digit is a 7. This digit is a 5. And our betting tree for the puzzle is a 6. Congratulations to anyone and everyone who bet 6. Zach also congratulates you after doing a spin. Alrighty, very nice. We've even got time for another puzzle.
So I suppose I should go dig us up another puzzle, and I will be back shortly. Welcome back. I have found another Niverio puzzle. Despite claims that I would likely not do a Niverio puzzle again for 70 million years, but we are here doing another Niverio puzzle, even though it is fewer than 70 million years. So here we have two things that we've encountered already, which are German whispers and thermos. So digits along this thermo have to differ by at least 5 from each other words. And digits on the thermo have to get bigger as you go along the thermo. Isabella predicts this one will take less than the 4 hours the last Niverio puzzle I did took, which is good. So a thing I notice in several of these boxes is that these digits are the same high-lowity. And so by that I mean, whenever you're doing a German whispers puzzle, it usually helps, and by helps I mean it's fun, to color the grid based on whether the digits are high or low. So 1, 2, 3, 4s are low, usually in blue. 6, 7, 8, 9s are high in orange. And along a green line, you always alternate. So these are either both low or both high. And what that means is that there's two universes. This is always, oops, sorry, I did not mean to fill in digits. Don't get excited, Zach. These are always either 1, 2, 3, 4, or they're 6, 7, 8, 9, because these two can only be those options. And this is the other one, because exactly the same argument applies over here. So these are always 1, 2, 3, 4, or 6, 7, 8, 9. And so that gives us a whole bunch of pairs to just start out with. And these are also a pair, because if one of the ends is a 4, this has to be a 9. If one of the ends is a 6, this has to be a 1. So this is a 1-9 pair. So we have that. Now, in the lower boxes, it is less immediately fascinating, because these are different high-lowities. And so we have to ask ourselves the question, is it possible that this is high and this is low? And the answer is, of course not. So definitely in this box, because these two have to be different, and I know this one is bigger than this one, this is high and that's low. Oh yeah, where are we putting a tree? Does a wandering Niverio have a claim or have a suggested bedding tree? Exactly the same argument applies over here. Let's see, row 7, column 6. This is our bedding tree for today. So don't bet 2, I recommend. Nell, I was too late to save Nell, but it will not be too late for you if you react quickly. So this digit has to be higher than a low digit and lower than a high digit. That's very helpful. I don't know why I made the 2 orange. Okay, and now we have a similar thing going on with all of these, where these are the same high-lowity, these are the same high-lowity, and these are the same high-lowity. But there's a little more flexibility with these in terms of what they do. But the given 2 sorts out a little bit about what happens in the universe where this is low, at least. Because if these are both low, this now can't be a 2. So this would have to be a 3 in that universe. But this could still be a 2, I suppose. That would be a 4 and a 9, I suppose. I'm not jazzed about that. Let's think about what digits are left. I'm not jazzed about that either, actually, if I'm being perfectly honest. Maybe I should look at, like, this cell in terms of what it implies about this column. That might be an idea. Maybe I should look at these in conjunction with each other. That doesn't seem great either. Oh, that's right. There's not even a pair in this column. But yeah, the digit up here is only from, I don't know, like 5 options. That doesn't seem super useful. I do have 3 lows already in this row if I'm trying to get my coloring game on. Okay, so Carl says this has to be 1 or 9. I believe that if it's high, it has to be a 9. If it's low... Oh, right. If it's low, because of the 2, it can't be a 3, because these would have to be 8 and 9, and that doesn't work. Okay, so the given 2 makes it so that this can only be 1 or 9 in 2 different ways, which are pretty cute. So if this is high, then we've said this digit on this thermometer is always a 4 because of the 2 cutting off the thing. And so that's a 4. That forces that to be a 9. If this is low, if it's not a 1, it's not a 2 either. It's at least a 3, but that forces this to be an 8-9 pair, and you'd need a half of a 16 in the middle of it or something. So that's not going to work. And so therefore, this is always a 1 or a 9. Sure. I believe that. Okay, so Ad 11 asks to contemplate the world where this is high. So if this is high, this is a 6 or a 7. And then this has to be a 1 or a 2. So this could never be 6, I guess, because if this were 6, it would immediately be a 1 above it. So this can't be 6. 7, though, 7 seems possible. But I do think it's worth noting this could never be 6, and this can never be 6. So if they're high, they have to be 7s, because they can't be higher than that. And so if this is high, it would have to go 7, 8, 9, exactly. Oh, 7's not possible either. Right, because if this is a 7... Wait. If this is a 7, it makes that a 2. Oh, right, okay. So, yeah, if this is a 7, then I need to have a 1 in the middle. Or a 2. But I can't have a 2 because I've put a 7 already, so I'd have to have a 1. But now I've ruled out... Welcome, Bridge Guy. The tree in box 8 is the cell that people are guessing what value it will have. Okay, so I'm not seeing this. The thing I'm seeing is a catastrophic mess of look ahead, and I think people are seeing something really elegant that I do not. 6 and 2 are allowed to be next to each other on a thermo, right? Oh, right. Okay, so I see it. Okay, so sorry. If this is a 7, that's a 2 and a 1. Right. Okay, yes. So, right. So, and then that doesn't work because then there's nothing to put here. So, right. So, actually, we proved it can't be 6 in a way I really liked. And then we proved it couldn't be 7 in a way I intensely disliked. But it can't be high is the point. And so these are both low. So these are both high. Oh, right, the same. Sorry, I was thinking this was symmetric. Last time I did a thermo whisper puzzle by Niverio, I was traumatized because it involved constantly copying things. So I was trying to just do it in advance this time. But it does not actually work that way. So this has to be a 1 or a 2, though, while we're at it. So 2 or a 3, 3 or a 4. This is an 8 or a 9. We can go ahead and fill in that's blue. Right, so now this can't be a 2. Because if this was a 2, that would be a 1, which would break this cell. I like that. So this is not a 2. So this is a 7. So it's high. And we get to do our little dance. Woo! That is our 7 dance. Yes, I understand that it forces everything. But we had to pause to do the dance. There's priorities, Tristan, priorities. So it's an 8 and a 9 and a 1 and a 6 and a blue. And so now these are blue. This is orange. This is a 9 and a 4, 3, 2, 1. And so we have locked that into the world. Okay, so now this has to be high, because it can't be 1 or 2. So this would have to be, if it were low, it would have to be at least a 3, but that's going to break the thermo. So this is high now, so it's 6 or 7. So these are all high, therefore. This is low. This can only be a 1 or a 2, though. This is a 7 or 8, and an 8 or 9. This is at least a 3, actually, from the column. This is the last... Oh, okay, I can do it. Okay, this can't be a 6. Because it sees 2 of these digits. If this was a 6, these would both be 1s. So where does the 6 go in this column? All the oranges are here. So that has to be the 6. And so that's the 1. And so we have that all set up. So this is a 2 or a 4, and it can't be a 4 because of the same reason. These would both have to be 9. So this is actually a 2. So now we have a 2 over here somewhere. Beautiful point. Martin points out this cell sees all the lows and all the highs. So this is the 5 of the column, which makes this blue. So that makes this a 3 or a 4. I was originally thinking this obviously couldn't be 4, but that's not necessarily true. This is an 8 or a 9, just by the column, because we've got all the things. This cell can't be 5 or high, because all the highs are in the column, so this is low. Sorry. Right, so this is low. And that's all the lows and highs for the column, so that's a 5. So now this is a 1 or a 2, and it's not a 1, so it's a 2. So that makes that a 1. This is a 3 or a 4. Same idea. I did not actually write it out, but that was also a 3 or a 4. That was the thing. What are these digits? They are 3, 4, and 5, so that's where the 5 goes. So these are 3 and 4. This is not a 2, so it is a 3 or a 4, because it's not a 2 or a 1, and that gives us a 3, 4 pair in the column, which makes that a 2. So these are both high, because they see every low digit. They see a 1 and 2 and a 3, 4 pair. By the way, the 3, 4 pair has made that a 9. But these see a 1, a 2, and a 3, 4 pair, and so these are orange. And they also see a 5, I should specify. That has made that an 8. That 8 can't be next to a 4, so that's a 3, and that's a 4, and that's a 3. That 8 looks over and makes that a 7. This is somehow a 3 because of the 4 in the box, I suppose. So that's a 4 and a 3. I need a 5 in one of these two cells, but who knows which one. So this can only be 6 or 7. It can't be 8. So this is 6 or 7. This is 7 or 8. But it can't be 7 because it's next to a 3. And 3 is not 5 away from 7, so that's an 8. This is a high digit that's not 6, 7, or 9, so it's an 8. And that's a 9. So now this is a 1. So these are both high. And there are 6 and a 9 in some order, but I have a prediction about what the order is because of the thermo. So that's a 6 and that's a 9. This is high. It's a 7 or an 8. Let's see. This can't be 1, 2, 3, or 4, and it can't be a 5, so this is high for sure. This is a 4 just by the column math. Yeah, this is very smooth. I like this a lot. I could have done without this part, but other than that, I absolutely have enjoyed the snappiness of this. Let's see. Okay, so these are lows because we need lows in the box, and we've got all the highs. And so that's a 1 because it's the only low left in the village or whatever. So this is a 2. So there's a 4 in there somewhere. This is a 6 or a 7. So 9 needs to go in this column. It only goes here. I mean, dislike is a strong word. There are parts I like less, we'll say. Okay, so Todd has a point about 5s. Is it about where the 5 goes in this box? 5 in row 5. Oh, it's where the 5 goes in row 5. Even better. 5 in row 5 is there. Very nice. So 5 in this box is in one of those two places. So this isn't a 5 because it sees every blue and 5, so this is orange. This is 7 or 8. I'm just going to record for my benefit. And for the record, there are plenty of parts I don't really like in my own puzzles. So it's not like, I feel like you can't very often do a puzzle that doesn't have like any steps that are sort of cringe in their own way. It's just a matter of minimizing them. 5, 6, 7. This seems to only be able to be a 4. So this seems to only be able to be a 7. This is a 6. So this is an 8. It's kind of amazing this resolves, actually, when you look at how little information there is in the grid. This can only be a 4. It's a naked single. Because it sees every low except for 4. It sees every high, and it sees 5. So naked single 4. I will always go for those. This is a high, because it sees every low and 5. And now this cell sees every high and 5, so that's low, and that's low. In fact, this is now just a 2, because it sees 1, 3, and 4. So that's a 3. Let's see. This row... No, I don't have anything in this row. This is a 7 or an 8 as well. It's a 7 or an 8 that's not a 7. So that's an 8 and a 7. That was an embarrassing thing to see by the magic of the pointing out things. Let's see. It's not a matter of telegraphing that makes me not like it. I don't like something that's like visualize several digits going into the grid and then go, oh, that doesn't work. It's something that I find mildly unpleasant to think about. Not that I'm unwilling to think about it ever. Like it was not that bad, but it's just not it's not the kind of deduction that tickles my brain in the way I like my brain tickled. Let's see. That sounded kinkier than I thought it was going to. That can be a 9. So that's a 2. Let's see. So we've got that done. Let's see. These 2 digits are a 7 and a 9. Oops. Let's see. This is a blue 1. We've got all the blues, so we need a 5 in here somewhere. It goes in one of those 2 places. Oops. Either that or we'll put 2 Ds into the grid. That's assuredly what I wanted. This can't be high or 5, because it sees 6, 7, 8, 9, and 5, so this is low. And as a low, it can only be 3 and 4. Let's see. I appreciate the random Ds flowing up or showing up. Let's see. Okay, so we've got. Let's see. There's no 2 there, no 2 there, no 2 there. So 2 is placed in this box. It's placed here, which makes this the 5. Have a good bed, Olima. I enjoyed your puzzle a lot. It was very nice. This is a blue 3. So that's a 4. So these are a 4 and a 7. I don't have that yet. These are a 3 and an 8. I don't have that yet. These are a 5 and a 6. I don't have that yet. It has pushed 6, though, thanks to this Jovi wing. It has pushed 6 down here. Nicholas makes a good point that I can color the rest of this column orange, which is very helpful. One of these is 6. Let's just go ahead and write in candidates for these. So that's... Oops. No, that's not what I wanted. So 6 or 7. And these are 6, 7, or 9. That one is not 9, I'm being told. So that gives me a 6, 7 pair. That's going to do it. Thank you, Nicholas. You got it. So that's a 6, 7 pair. That's a 9. But more importantly, this 6, 7 pair looks over here, which makes that a 5, which makes that a 6. Is that a 7 and a 6 and a 7? This is a 7 and a 9. That is a 6. So these are a 7 and a 1. These are a 3 and a 4. These are a 1 and a 6. And now that's going to do it. So now I can blue-orange. And I can just preemptively blue these, because I know they're going to be blue at the end of the day. The bet cell's going to be orange. This is going to be the 5. So that is going to be a 1, which is going to come up here and make this orange and this blue. So that is a 7 and a 1. So this is a 4 and a 7. This is a 3 and a 4. This is an 8. This is blue. Let's see. This is a 6. That's a 3. And the betting tree, which I have to say looks very posh on top of the orange in the middle of the blue-orange, is very nice, making that an 8. That was very fun. I enjoyed that a lot. Very smooth, which I greatly appreciate. Everything fit together nicely. And I got to color a lot. Yes, I like smooth puzzles like this. The smoothness is always very exciting. And in fact, it was so smooth, I actually have time for another puzzle. So I'm going to go fetch us up another puzzle. I'll try and find something in the bucket that is listed as being fairly quick, and then I will go do that. And then I will eat pizza. It is true, I have colored even more than normal today. I mean, we started with a puzzle where I got to color the entire grid, then erase the coloring, and color the entire grid again. So, you know, that was a good way to start the day. I will be right back. Alrighty. Next up, we have a thermo puzzle by PaperScissors. This might be PaperScissors' debut on the channel. I'm not 100% sure, but this looks like it'll be enticing and fun. So we've done a lot of thermos today. I feel like we don't see thermos very often, but we've seen a lot of thermos today. So the digits have to go from smallest to biggest along the thermos. There are a bunch of them. That's it. That's the rules. So we've got to look for places where 9s and 1s are restricted. So 1s in column 6, I am noticing, are restricted. So I can never put a 1 partially along a thermo. So 1 in column 6 can only go in one of these two cells. Let's see. Oh. Beautiful, beautiful. Okay, Isabella has the better observation, which is where does 9 go in row 8? 9 can never go too far, or 9 can never go anywhere but the end. So 9 can actually only go here, and we get to do a 9 dance. Woohoo! Woo boop doop. Woo! Woo boop doop. Woo! Ba da ba da. Wah! Ba da ba da ba. Wah! Ha ha! Wee! Ba da ba da ba da. The 9 dance is the one where Zach gets to do front flips. Those are very exciting. Woohoo! So we now have a 9. So now we should probably look and see what tips does this see? Does this do anything exciting? 9 in row 4, points out Nicholas. Yes, Camille, the numbers along the grid are just so that when someone refers to row 6, column 7, it's a little easier to find. It's not such a huge deal when it's a 9x9 grid, but for example, earlier we did a puzzle in a 10x10 grid, or sometimes there aren't these big guiding lines, so it's just helpful to have it around and doesn't hurt anything unless there's a bunch of numbers on the outside. Ambrose did this one a year ago. I have no idea how this one got added to the bucket. I don't recall. We wanted to do Nicholas's point. Nicholas's point was that 9 in row 4 is placed here because this is the only place that it can go. Let's see. Does that do anything interesting over here? Oh, let's see. Fancy point from Carl. 1 in column 4 is actually placed because it can't go here because it was already claimed in column 6 in this box. So that's a 1. 1 followed by 2 followed by 1 in box 8. Okay, so now where is... let's see, one of these two is 1. Oh, 1 in box 2. Got it. Okay, so the 1 in box 2 is over here. The 1 in box 7 is here. Or sorry, box 8 is here. Which we got a different way than what Eric had intended. Oh, sorry. Somehow in my brain, when I read that, I said followed by 2. I thought I was supposed to be able to place a 2 somewhere and was confused. I can't place a 2 here for whatever it's worth. I might be able to place a 2 in one of those places, though, or there. Let's see. Is 9 doing anything interesting in this box? Not quite yet. Let's see. Forgot to be you again. 1 restricted in column 2 is a good call from Camille. 1 in column 2 can only go up here. Welcome, Camille, by the way. Oh, we didn't put a bedding tree down, by the way. I'm feeling this cell. So if you would like to, you can guess what digit will fill this cell at the end of the puzzle. For bragging rights. I'd say for bragging rights and something else, but really it's only for bragging rights. Let's see. 8 in this box is restricted to this sort of collection of things, which is kind of interesting. Let's see. Screaming Ice Cube says in row 8, I've got to put an 8 in one of these cells. That is correct. And so when I do put an 8 in one of these cells, it's going to put a 9 below it. So the only places I can put an 8 in this row are here and here. And so the only places I can put a 9 in this row are here and here. We'll mark that like this. We'll give them each a flash. And so we'll corner mark 8s, corner mark 9s. I am sorry your betting is not going well. Yeah, the little, like, color... This is one of the handier features of colors, is, like, use it to mark esoteric collections of digits. I keep hoping I'll be able to, like, think about 2s at some point, but I keep not quite being able to think about 2s. You don't quite remember the full grid from 11 months ago. I mean, I think it would be a bigger concern if you did remember the full grid from 11 months ago. Let's see. 1 in there isn't very interesting. Yeah, what am I meant to do here? Like, should I just mark where 1s can go in every box and see if anything interesting pops up? That does not seem good. There. Oh no, these go there. Let's see. 1 over here, I guess, is sort of restricted to these cells at least. It does sort of feel like this is going to end up being a, like, skyscraper or something. But I do not yet quite see what I am meant to see. like 9 in this column is kind of interesting. It can't go there or there or there or there or there or there or there. So 9 in this column actually can only go in 2 places. Let's mark that. That seems like it's potentially going to fill into Eric's point that maybe this is setting up a classic technique. Because once I realized, and by once I realized, I mean once it was pointed out to me by chat that that these 9s are in one of those 2 places, that rules 9 out of there. Okay, so we want to put 9s in row 2 now. Camille suggests. Okay, so 9 in row 2 could be there. None of those spots, or there, I think are the spots 9 can go in row 2, or any of those obviously not 9s. I'm looking at the 9 in row 2. Okay, so this is the 9 in row 2. Give that orange. And then row 9's 9. Okay, so yeah, so this is a finned X-wing. So here's the way to interpret that. I don't know if I have absolutely no idea if it's going to do anything. It may do absolutely nothing, but it might do something. But what it means is we have 2 possibilities. If you imagine that this cell was not able to be a 9, we would have an actual classic X-wing on these, which would rule 9 out of every cell in these columns. It would claim the 9 for these 2 columns, is how I like to think about it. But we don't necessarily have that, because we could have a 9 here, in which case then the X-wing is broken. And so the question is, what meaningful commonalities are there in terms of eliminations I get for 9s between these 2 things? And so the answer might be that there aren't any, but it's a good thing to spot. So, like, for example, this cell can't be a 9 because of the fin. No, that's not even true. Sorry, I was going to say something that was wrong. Yeah, there might not be many. Like, this cell can't be 9 because of the finned X-wing, for example. Is that interesting that this cell can't be 9? Those can't be 9. Oh, here's an interesting thing I should think about. Where does the 8 go in this row? So 8 can't go here. Because of our finned X-wing. I have no idea if this puzzle... I didn't write down an intended difficulty or whatever for this puzzle, so I have absolutely no idea if this is really intended in this way. So this might be a very simple puzzle that we are way overcomplicating, but hey, it's fun. So that can't be an 8 anymore. That can't be an 8. That, of course, can't be an 8. That can't be an 8. That can't be an 8. And so we're always, with our 8, going to place a 9 in one of these 3 places. Oh, interesting. So the 8 in row 4 places a 9 in one of these places, which aligns with the 9 in column 9. And so that actually eliminates 9 from all of these cells. Those cells can't be 9 for the box. Of course, those cells can't be 9. So the 9 is at least pushed into this corner for whatever it's worth. row 1, column 2 can't be 9. Yes, this is eliminated by the finned X-wing, because it both the fin and the X-wing eliminate 9 from it. Carl is correct. So for the box, 9 can go in one of those places. There was some discussion about 2s before when we were describing finned X-wings, but I have since lost track of it. C'est la vie. Let's see. Yeah, this sort of constellation of places where things are restricted is getting very interesting. Is it possible that this is just a swordfish and there's a place where you can sort of add to this to complete the swordfish? Set? How could this possibly be set? Let's see, 8 in row 2 is restricted. Oh boy, could this be the checkerboard set? That would be fascinating. Okay, Okay, so let's clear the coloring and let's draw in the checkerboard set. I've never done a puzzle where the correct thing to do was the checkerboard set. So let's try and do the checkerboard set and see if it helps. Might not. We'll see. So here's how this works. So we're going to take these columns and highlight them. All of these that's 4 total sets of the digits 1 through 9 in the complete grid. This is also 4 total sets of the digits 1 through 9 in the complete grid. And these, it's just an innocent little thermo puzzle. How bad could it be? So those are gone. And so all of these, as well as that one. It does look like a tablecloth like this. Fortunately, I've got 2 glasses of tea. So yes, so here's the point. I thought checkerboard was the right name. Is this not the checkerboard set? But it seems very relevant because all the bulbs are in blue and all the tips are in yellow. And so if all the bulbs are in blue and all the tips are in yellow, well, that's interesting because what? So how many non-tipped things do we have? So yeah, so let's highlight the non-bulb squares that are involved in the set. So there's that one, there's that one, there's this one, there is Ye Old Bedding Tree, and there is this one. So you have to imagine, in order to think about this, and it's going to take a little bit for me to sort of wrap my brain around this too. What you have to imagine is that you straightened all of these out and laid them out in a row so that you... also row 7, column 4. Good point. And laid them all out in a row and thought about what the digits were that you had. And so every blue digit comes with a yellow digit that is at least 2 higher than it. The blue 9s should be marked, yes. I did not do a very good job of highlighting all of these. And so... So let's see. So how does this work? So you have to sort of... This is the same idea as that codec puzzle herringbone. And also, I think the Fistamafel puzzle spoons also used this idea of the fact that you having all of these forces, those thermos, to be very, very close to consecutive. I'm trying to figure out exactly how this works again myself. Right. Okay, that's a good way to think about it. Nell has the right way to think about it. So every yellow digit on a thermo is at least 2 bigger than the blue cell on thermo. I think Camille also said this. So I count the number of thermos I have, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 thermos. And so if I sum the blue digits, and I sum the yellow digits, the sum of the yellow digits has to be at least 32 more than the sum of the blue digits. And so, because yellow and blue actually have the same sum, that means the opposite is true for these squares. So I'm going to give these squares an orange flash, and these squares, I was going to say a blue flash, but that's not a word, a purple flash. And so these have to go the opposite direction. They have to make up the difference. So the sum of the purple cells has to be at least 32 more than the sum of the yellow cells. Yeah, the betting tree was not well chosen. Whoever would have guessed that this was going to turn out to be a checkerboard set. So the maximum I could make the purple cells sum to is 4 times 9, which is 36. The min I could make the 4 yellow cells sum to is 4. And so the absolute maximum I can make this difference is 32, but that's also the minimum. And so the effect of this set is that we get immediately all 1s and 9s in... Why are you not giving me a 9? In these. So the betting tree worked out, unfortunately, to be a 9. Apologies. It also means that all of these thermos are actually Renbon, because if even a single one of these thermos did not go completely consecutively, we wouldn't get to our bound that we were trying to get to. We would lose. So actually, we can now place that this is a 1, and now it has to go 2, 3. It has no choice. This is a 9 by our pencil marks, I believe. This is not a 1. This is not a 9. And so we get this. There's a 9. There's a 9 in this column, but I don't know where it is just yet. Let's see. Okay, so where... 9 in box 5. 9 in box 5 has been called. 9 in box 5 is just placed here, so that goes 9, 8, 7. Did I abuse a pencil mark? That is very possible. Let's just delete all the pencil marks. That's probably the best way to go about this. Rather than risk it. The point from Medi about 9 in this box still stands, though. 9 in this box still goes here. The point about 1 in this box still stands. Sorry, 2, 3. Let's see. Where is 9 in this box? I guess it still has a few options. 9 in box 2 now. Yes, 9 in box 2. is in one of these two cells. And it's not that one, because a 9 there would put an 8 there. So this is 9, 8, 7. Let's see. 2 in this row is going to be tricky. How am I placing 2 in this row? I can't place it there. I guess 2 in this row is going in one of those two places. Let's see. 9 in box 3. Good. And so now 9... No, not quite. 9 in one of these two places in this box. 9 in one of these two places in this box. Two down in box 8. So 2. Well, it's not there. It's not in those two cells. So 2 in box 8 is in one of these two cells. So, right. But 2 can't be here because it can't have a 3 after it. So 2 is there. That was a good spot. Okay, that would have taken me a while. So that goes 1, 2, 3. Let's fill in the column. 4, 5, 6, 7. That is not a 7, apparently. So this is a 3, 4, or 5. This is not a 7, apparently. This can't be a 4 because the digit before it would be a 3. Two in box 5. Yes, 2 in box 5 is placed. So this column, 2, 3, 4, 5, 6, 7 as well. That's not a 7. This can't be a 4. This can't be a 4 either. So this can't be a 7. While we're doing things that can't be things. Let's see. These digits are actually not that... There aren't that many of them. 2, 3. Could this be the 3, 4, 5? Annoyingly, yes. These are 3, 4, 5, 6. Let's see. 3, 4, 5, 4, 5, 6, 5, 6, 7. This can't be a 6, though, because that would need to be an 8. I believe Eric's point, although I don't necessarily want to use it. Because it seems annoying to prove. It may be that it is, it may be worth thinking about, but so far it has not seemed like we have been so slow that it has been necessary. Let's see, 8 in box 8. 8 in box 8 is an excellent point. That is the 8 in box 8. So let's see, what is this able to be? 2, 3, 4, 5, 6, 7 is the... Oh, it can't be 7. 4, 5, 6. Okay, yeah, that makes sense. But if this were a 5, that would be a 6, and then this would be a 4, 7. That doesn't work. So this certainly can't be a 5. And so once this can't be a 5, that can't be a 4. And this can't be a 6. Let's see, so... This is either 6, 7 or 4, 5. And then this is the other one. Yeah, every bulb and pair is certainly the same parity. I agree. The start and end have to be the same parity because they differ by 2. I agree with that. Let's see. So this can't be 5, 6 either for the same reason. Is that true? 4 and 5, 6 and 7. Yeah, this can't be 5, 6 either for the same reason. So this over here is 3 or 5. Yep, same logic. Row at column 4 is not that. Okay, so if these were 4, 5, that would make this... Oh, no, that would make this 6, 7. And if this were 6, 7, it would make that 4, 5. That's right. Okay. Oh, hey, JC, welcome. Can't be 4. Right, because the thing below it can't be 3. Very true. Which places the 4 in box 5. Okay, so the 4 in box 5. Hey, SBQ. Sorry, that can't be 4. I agree that that can't be 4, because this couldn't be 3. Places the 4 in row 4, 6. Oh, right. So one of these two is 4. So that's not a 4. It's a 3, 5, or a 6. Sorry, I missed when you said it that you said row 4, 6, column 6, and I was thinking I knew which of these was a 4. And then being slightly confused. Let's see. 1 in column 3? Let's see. 1 in column 3 is not in any of these places. It's not there. It's not there or there. Oh, and it's not there either, because that would need to be a 2. So 1 in column 3 goes there. Very good spot. Is that all my ones? No, I'm missing 2 ones, I think. So yeah, if this were the 4, this would go 4, 5, and that would be a 6. So I'm trying to think if I feel like we should really prove that the middle of all of these things is even. Because I feel like we kind of did that down here in a way that suggests that maybe it's not that terrible to prove. So what would happen if one of these bulbs was a 2? I'm not quite sure I see why it has to be exactly this this 1, 3, 5, 7 pattern that is claimed. Let's see. Carl says the 2 remaining ones make row 5 column 2 or row 5 column 8 a 3, right? Because the problem is the 1 could be there. Yeah, if the 1s are there and there, that does not work. Oh, actually, no, Carl's point actually solves it. Because the 1s are either here and here, or here and here. Well, they can't be here and here, because that would put 2 3s in the same place. So the 1s are here and here. And go 2, 2, 3, 3. Okay, so Carl saves us. Let's see. So this seems to be able to be a 3, 4, 5. As best I am able to determine it. So now we've got all the 1s. 3 in box 3. Okay, so 3 in box 3 is not in any of those cells. So 3, and it's not in those cells either, so 3 is there. Got it. 3, 4, 5. That was cool, with the X-Wing, realizing the X-Wing would duplicate the 3 if you resolved it in that way. Or sorry, the Jovi Wing would duplicate the 3 if you resolved it in that way. I need a 3 in this row, and there's only one place it can go, because it can't go there, and if it went there, I'd put a 2 there, and it can't go there either. So the 3 is here. So this goes 3, 4, 5. As foretold, this digit is even, so this digit is odd, but it can't be 5, so it is 7, 6, 5. So this is 3, 4, 5. This is 5, 6, 7. That's a 3. That's a 6. It's a 4. Let's see. These digits I can just write in once I know what they are. They are a 5 and a 6. So that's a 5, 6, 7. This column is missing 6, 7, and 8. So these are 6, 7, and 8. That one is only of those an 8. So this is 6 or 7. But it can't be 6, because then it would go 6, 7, 8. That doesn't work. So it has to go 7, 8, 9, and a 6. These two digits are a 4 and a 5, which have to go in that order. These two digits are a 2, which has to go there, and a 4, which has to go there. This is a 2. These two digits, 4, 5, are a 6 and an 8. I think somehow that's not resolved. Let's see. Isabella says row 2. Isabella is correct. I should fill in row 2. 3. This is a 4. Let's see. These are 5, 6, 7, 8, 9. Which, as predicted, has a lot of red involved. This is not 7, 8, or 9. This just is a 7. How about that? 6, 5. So that's just an 8, 9, 7. That's a 5, 4, 3. This is a 6. 1, 2, 3. Let's see. One of these needs to be a 4, and it's that one. 5, 6, 7, and that's an 8. This is a 2. Pizza. Let's see. I need a 2 in one of these, and it's that one. 3, 4. That's a 5. No, it's not a 5. Try again. 6, 7, 8. It's an 8 this time. It was a 5 last time, but it didn't turn out. That is a 6. 5, 6, and that is a 7. See, if chat tells you it's a set puzzle, it's a quick puzzle. That is the secret. Yeah, this is quite similar, just a slightly different version of Mitchell Lee's thermo puzzle that used a similar idea, which also, as I mentioned, has shown up a few times, of the sort of figuring out, like, if you can somehow, and this does it with set, but Kodek and Fistamafel, I think, did it with other kinds of geometry, sort of put pressure on how much difference you can really put between the ends of the thermometer, then you can do this whole sum trick. I did a Playmaker puzzle with this secret in it too, I think. So it is come out. Yeah, the working without givens is pretty cool. It turns out that these cells all, like, we were able to place some digits at the beginning. I think I agree with Math Pesto. It would have been nice to put set in the title. I think in a perfect world, you would have been able to get absolutely nothing without the set, because we seemed to be slowly picking away at it at the beginning, so I wasn't feeling like, oh, we're not getting anywhere. I was with 2 to 10th that I was thinking, oh, this is going to be setting up like a skyscraper or something like that. And when we found the finned X-Wing, I was like, oh, maybe it's that. And then even when set was suggested, my original reaction was, it can't be. But then, of course, as soon as you draw the set into the grid, you're like, oh, yes, it absolutely, absolutely is that. it really could not more be that if you sort of know that this is a thing you can look for. But yeah, it was a neat use of the idea. And it's super fun getting to like fill in a whole bunch of thermos completely in a row. I was just debating if you had just said at the beginning that this puzzle was a Renban thermo puzzle, where all of the thermos were also Renban. I was debating if that would have been a significantly different puzzle or not. And I think the answer is you still actually need to think about it more deeply than just that. I don't think it's only that you need in order to solve the puzzle. I think you need a little bit more of a sense of where these digits are to get started. Anyway, I had a fun stream today. I hope other people enjoyed it as well. I'll be streaming again on Friday at the same time. So I look forward to seeing you all then. I look forward to seeing what has been voted on by the various supporters. So I should say thank you again to those of you who support us in any way on the Patreon, on the YouTube. I love seeing how many green names there are in chat. If you want your own green name, you can click the join button down below and you can get a green name and get access to the fancy Zach emotes that are getting spammed all around. Thank you to those of you who support us at the ultra high level. So those are our turbines, David Ratner, Michael O'Connor, Nordy, Franco, and Woofer. Thank you so much for that. If you could leave a like on the stream on your way out, that would be much appreciated. If you're new and you'd like to subscribe, that would be great. It's much appreciated. I've been seeing our subscriber numbers tick up bit by bit, which has been very exciting to see. Again, expect news about stream merchandise in not too distant future. But for now, I will let you go, and I will see you all on Friday. Thanks for watching.